what you got going on. High nose, eyes closed, holding on. And I don't want another date and break. And take off, steal off, night away. What you got in store for me? Keep those eyes closed next to me. And I don't want another day to break. Take off, steal off, night away. Warm shadow. Warm shadow. Won't you cast yourself on me? Won't you stop breaking in? Red sky, red light, awakening. And I don't want another day to break. Take off, steal off, night away. Oh, shadow. Oh, shadow. Won't you cast yourself on me?
Hello, just a question. Can you hear me?
Yes, I can.
I can answer.
Okay.
Oh, okay. Sanket did it.
Can you hear me as well?
Yes.
Yes.
Excellent.
Now I jump. Good morning, everyone. Can you hear me? I think you are muted from there, Sanket. Shatul, can you turn my microphone on? Hello, everyone. This is Farhan from Smart Innovation Norway. We are just starting in a few minutes. So yes, we can hear everyone connecting and we can see you as well. We will be starting very soon. think we can. Hello, everyone. Welcome and good morning from Smart Innovation Norway here in Halden. I am myself is Farhan Farouk, researcher for Smart Energy Technologies, and we are just starting in a few minutes with the event here from our location headquarters in Halden in Norway. We are really delighted that you are able to join us for the final event of Resolved Horizon 2020 project, which is funded under the European Union's framework of Horizon 2020 Research and Innovation Funding Scheme. So today we will have a list of many discussions and presentations given by our partners of the consortium connected with this hybrid digital event throughout Europe. So we are really excited to have you all here, and we really look forward to have a great event with you moving forward. As I mentioned a bit myself, so I'm a researcher for Smart Energy Technologies. Within the Resolve project, I'm connected with the partner and my host organization here, Smart Innovation Norway. And today I will be the host of the event, and I will try to keep as smooth the things as I could. And if you have any questions before we move on to the actual day, please use the Q&A function for all the questions that you want to ask to our panelists. And if you have any questions related to technical difficulties or any other challenges that you face and you are not able to be able to follow the event, for all our attendees and also our panelists, if you have any questions, please feel free to write in the chat, and our team here will try to assist you and try to help you and have a smooth event. So with that, without any further ado, we would like to kickstart the event and today's day. So I would like to invite my colleague and the Deputy Head of Research and Innovation at Smart Innovation Norway, and also a key person in the Resolve project as the Innovation Manager. So Heidi, please, floor is yours, and let us know what we are looking forward to today.
Thank you, Farhan, for the kind introduction. Dear audience, it is my great pleasure as the Innovation Manager of H2020 Project Resolve to welcome you all to this final event. I would also like to warmly welcome you virtually to Smart Innovation Norway's premises in Halden, Norway. We have an exciting day ahead, and we have plenty of interesting presentations to hear about. We will start the day with an overview of the project, and after that, we will dive right into the exciting stuff. So we will start talking about the piloting of the project outcomes. After this high-level overview, we will dig deeper into the results, and you will hear a lot about the great achievement the project partners have achieved during the project. In the panel discussion, we will engage with experts in the field of low voltage grids to discuss the topic of accommodating renewables in the low voltage grid. In the end of today, you will hear more from me and my colleague Sanket in the role of managing innovation and exploitation of project results. Before I give the floor to the next speakers and the great, more technical presentations of today, let me emphasize the motivation of organizing this event. Resolve Consortium sees great value in the project outcomes, and we are actively seeking for further exploitation opportunities for them. We aim to provide you all information and inspiration for future collaboration with us in order to fully exploit the potential of Resolve solutions. I hope you all have a great day with us, and I hope we meet again soon. Thank you.
Let me kickstart the day with the project coordinator from our great city and the country of Spain, and our great partners from the University of Girona. So Quim, Dr. Quim, I hope you can hear me, and also we can see you right now. Can you please try to speak or open your microphone?
Hello, Farah, thank you. Yes, I'm trying to share the screen, but I think it's not possible if you are sharing it.
Yes, no worries. We will de-share and you can take the floor, and Professor Quim will be telling us a bit more about the overall project and how it has achieved many things. So Quim, floor is yours, and please feel free to share your screen now. We are just de-sharing from our side.
Okay, thank you. Still, it seems that I cannot share the screen. Now, yes.
Yeah, now you can try.
Yes, but the same message appears. You cannot start screen share while the other participant is sharing.
Mm-hmm. Just a second, maybe because we are trying to, I think, keep the loop here from the headquarters, but I think my colleagues are trying to help you there. Just a second. So we will, yeah, you can try it now.
Yes.
Yes, we are seeing it's coming up right now. And can you put it in the presentation mode?
Yes. Can you see it now?
Yes, we see it. Perfect.
Thank
Go
you.
ahead.
Thank you very much. So thank you, Farhan, for this introduction. Also, Heidi, for introducing the project and the objectives of this interesting session, where we want to share with all the audience the results we get in this project. So good morning to all the attendees, and welcome to this final event of the Resolve project. As project coordinator, it's a pleasure to be here and see the interest raised by our project and the results we want to share with you. So it has been 3.5 years of intense and fruitful work doing research, developments, integrations, tests, innovations, and also always having an eye put on the evolution of this electricity market. So it's it's emotional to be there and show you the results of this project. So let me start with the motivation or the goals of the project we have from the very beginning. And this is motivated by the current situation, by the energy transition situation where we have the necessity to increase the share of renewables, to increase the production of renewables, this kind of energy that is difficult to control. And this transition will start, we think, by the empowerment of the consumer, of the citizens. So we envision a future with a lot of renewables at the last part of the grid, with the problems this produces in the management of this grid. So this is our focus. Now, our goal at the beginning was to improve the efficiency and hosting capacity of this distribution network, the low voltage network, where the customers are connected, and giving additional capabilities to the grid. In particular, we want to add control capabilities and manage flexibility in this low voltage grid. And to do this, we propose to develop some new power electronics capable to manage more efficiently the grid and manage also storage, batteries, different kinds of batteries in the same package, in the same location, providing the grid with more efficiency and more additional capabilities that are necessary for the transition. This was our vision at the very beginning, and I think it's still the same. This was in 2017. This is the draw we did to start our proposal. You can see these low voltage grids with different deployments, and the challenge was to increase the observability of these low voltage grids. So we decided to develop new instruments. In this case, they were PMU, synchrophasor, and power quality monitors, low-cost devices to be deployed massively in this grid. But also we want to exploit information coming from the already deployed smart meters. So the idea was to use the information from smart meters to do generation and demand forecasting. We also at this moment want to act on the grid. So we put as objectives, as a challenge, the development of this new power electronics device capable to introduce control in this low voltage grid, also compensating, balancing energy among phases, providing power quality services, and capable to manage different kinds of batteries in order to provide flexibility to this grid. Also, we at this moment we think in the possibility of changing the configuration, so acting on the switchgear installed in this low voltage grid. So you can see that we were proposing a low voltage smart grid. Okay, to do this, with this new observability capabilities and acting capabilities, the next point was to manage this information. So we propose also an optimal operation of the grid in the sense that we could change this configuration, act on the switchgear, but also schedule the charge and discharge of the batteries to accomplish with specific goals for efficiency, for loss reduction, for peak reduction, and so on. Okay, and this should be possible by maintaining the current system, the legacy systems, so working together with information coming from the SCADAs and also from the information provided by the metering infrastructure. So it was a technological challenge to do this integration that should be compliant with the current standards, and in case of not existing standards, providing the standards to do this. And also this should be cyber secure. Okay, so this was our challenge. At this moment, this was a technological challenge, but also we should be oriented with the current trends, with the current necessities of the DSO. So this should be a business-oriented research. To do this, we join. Maybe you see the video in the introduction. No, this is our consortium. You could see on the left the people that close to the business. You know, Stefanelli is the DSO. They put the requirements and they manage the pilot where we deployed the results. Smart Innovation Norway take care of the exploitation of the business models of our technologies. In the central part, you can see the people in charge of developing software. This is Intracom, a large ICT company in charge of developing designing the architecture and doing the integration. Joannem Research was responsible for the cyber security, and University of Girona, we develop the algorithms and we take care of the coordination. On the right, you could see people in charge of hardware. Consensus did the developments for instrumentation, PMUs, PQMs, and gateways. And the University Politècnica de Catalunya, they develop all the power electronics and the management devices for the batteries. This is the people. So these were the institutions. These are the people that has been involved in the project. So thank you to all. And you will see the speech. We followed from the whole project the methodology of the SGAM. I don't want to go into details, but just to put emphasis that we follow this methodology, so we guarantee the interoperability of all the developments. And this is our solution. You could see in the front panel, in green, the developments we have done during the project. In blue, what is the legacy systems, the SCADAs and the AMI, the advanced metering, smart metering infrastructure. On the right, you could see the part that represents the algorithms, the software, the intelligence. In the right bottom part, the hardware, the power electronics and the management, the batteries. In the central part, the PMUs, PQMs, and gateways. And on the left, the integration results provided by ICOM that guarantees the interoperability and the flow of information through the ESB. Just to finish, this is the functionalities we get from all the integration of these technologies. We are capable to detect interruptions of intentional and controlled idling. We reduce technical losses through the activation of these power electronics. We are capable to prevent congestions and under voltages through the storage, the utilization of these batteries, and changing the grid configuration. Also, the power electronics provide support for the continuity of supply when these uncontrolled islands appear. We do voltage control through the injection of local reactive power, and we can improve the power quality using this power electronics. And then we have a package or block that helps in detecting faults in the systems, and also to prevent this congestion and over voltages. And this matrix, you can see the technologies used for each of these functionalities, and these will be developed in the following sessions. So just to conclude, I want to mention that all of this has been integrated, is running in the headquarters of Stevenage. So you have a pilot in one of the areas that the company provided, and all is fully tested in this environment. So this is our achievement today in 2021 after these 3.5 years. And this is all from my side. So thank you very much. And I hope you enjoy the following sessions.
Thank you, Quim. Thank you very much, Quim, for this very nice introduction, I think, of the project. And it's really important, I think, to highlight that despite this COVID-19 pandemic, the Resolve Consortium has been able to progress and do some actual piloting on the site. So and this is something that I think it's very important to mention for all the European innovations or innovations developed across the globe, is that we are able to develop that innovation, but then test it in the real life environment, because then that's where I think the real value back into the society, a sustainable one that we all want to build on. So thank you, Quim. And I think with that, we can move on to very relevant topic of the day. And that would be to see and learn and also hear from our partners of Stebanel, and then how they have deployed these technologies, the use cases enabled on their headquarters, and then how they have seen the use of this technology for their benefits. So if we now look to the next speaker, it's very fortunate for me to welcome my ex-colleague as well, that we had a chance to study as well, but now we are working in this Horizon projects. So Joanna, I hope you can hear me, and welcome to the event.
Yes, I can, Farhan. Thank you.
Thank
you hear me fine?
Yes, we can hear you very fine, and we can also see you here. So welcome
Awesome.
to the event. And without any further ado, I will also de-share our screen from here, so you can try to put your PowerPoint sharing from your computer. So meanwhile, while Joanna is sharing, so if you are just joining in, so I welcome you again to the Resolve Final event, a project that is funded by the European Horizon 2020 framework. So we will be taking care of different topics today throughout the day. So right now we are starting with Joanna from Stebanel, and we will be discussing about the use cases and the piloting. So Joanna, are you able to share your screen now?
Yeah, I cannot be sharing my screen right now. There's like an error. 1 sec.
You can try it.
It's from my side or your side. I'm not sure.
You can try it once more.
Yeah. Okay. Yeah. 1 minute.
Otherwise, if it's something error from your side, we can share it for you, and let us know. We can move it for you, Joanna. So meanwhile, Joanna is figuring out the technical difficulties. That's part of the pandemic, and I think the hybrid digital event. So we are just going to have a break after this presentation by Joanna, and then we will dive into a bit more detail on each of the key innovations that were developed, and then how that could be used for your benefit. So Joanna, you are back. Can you?
Yeah. Sorry for that.
No
I don't know.
Yes, we can see your screen.
You can see. Yeah, perfect. Okay.
Can you put it in the presentation mode?
Yep. There you go. Okay.
Yes.
Can you see it now?
Yes, we can see, and floor is yours.
Okay. Thank you very much, and sorry for the technical problem. So hello everyone, and thank you, Farhan, for the introduction. I'm Joanna, and I'm here together with my colleague Ramon on behalf of Stavane. Stavane is a Spanish company that has been part of this project, as Kim has already said. And before going into detail on what have we been doing and our role, I'll short introduce the company. So Stavane combines both the role of distribution system operator and retailer on the electricity domain and the telecom operator, providing dark fiber and PLC-based telecommunications. The main business is indeed the electricity distribution, but for the last 10 years, we've been collaborating with several technological sectors to test and develop telecommunication technologies. So our technicians have been actually performing pilot testing related to remote management and have gained awareness on the important challenges of rural areas and dispersed communication. And regarding this specific project, Resolve, we've been playing a role in the operation of the low voltage grid and leading the validation of the technology in relevant environment, as Kim has said. And why did we get involved in this project in the first place? Well, as many of you may already know, the low voltage grid is the very last part of the electric grid that delivers the energy to the end consumers, our houses and our industries. And what you may already know as well is that this very part is the one that has the lowest observability and control, and at the same time is subject to major disruptions and renovations. So adding to this, the growing distributed energy generation in this network is actually challenging the initial designed one-way direction of the system in terms of the power flow. And this has some significant impact on the voltage and quality of supply and current conditions, and this affects part of our equipment. So this is a real issue for DSOs like us, and that's why we joined Resolve to try to change this. So we joined Resolve to help develop a smart and dynamic low voltage grid, as Kim has already said, where not only the data can be collected, but also the interaction with the grid and the anticipation is really important. So to do that, we have contributed with our network, a part of it, specifically a part that is located in the north of Catalonia, as you can see in the map. This grid is composed of two three-phase lines deriving from two different substations, and each one of them has both supply points and PV installations. Some years ago, those substations had to supply two high load factories that are now closed. And this is important because that's why the two transformers are a bit oversized with respect with the actual load of the area. So this pilot has undergone some changes in order to test these technologies and some specific scenarios. The main one was to connect the two radial lines with this yellowish line that you can see in the picture. That was to have the shape of a ring of the whole network. And apart from that, to remotely control and reconfigure the grid, moving the borders, there were three fuses that were actually changed by motorized switch gears that you can see marked in the picture in red. there's one on each of the lines. And apart from that, the components that are in charge of measuring and gathering that data that we were talking about, that are provided by our partner Consensus, are the phase measurement units, the PMUs, and the power quality meters, the PQMs, that are installed on both the 2 existing already lines and the new one. So all these analyze the power waveform and are used to detect sudden variations of the generation and demand, and they make it easier for us to detect faults in the grid. All this generated data, together with the data that is coming from our smart meters, is managed by the Resolve platform that is developed by another of our partners, ICOM, that it's the one that provides the instructions regarding charging or discharging batteries and the actuations of the interconnection elements. So together with this measurement equipment, the PED, the power electronic device, and the batteries that are developed by UPC, I think they're going to talk more into detail of that in further on. This is the main hardware of the project. On the screen, you can see the actual disposition of all this hardware in one of the substations. The lithium ion and the lead acid batteries are installed together with the PED on the 2nd floor. And the batteries and the BMS are electrically connected to the PED by a cable that goes through the floor. And all the communications connections are converged into the communication box. And we keep control and track of all this hardware activity through the SCADA platform. With all these technologies, as Kim has already said, the main goal is to aim for a smart and dynamic low voltage grid. And for that, we needed to evaluate the impact of this project in our distribution grid. And to do so, we have been, and we're still finishing some tests, performing tests regarding efficiency, planning, and quality service. To test the efficiency, the improvement of energy profile in the substations, and the reduction of power losses to a better waveform and quality are being studied, are being quantified. And we did this by using the measurement equipment that we just mentioned, both the one upstream and downstream of this PED, to quantify the actual improvement in the energy management. To test the planning, the impact of the planning, we've used applications like the weather forecast or the prediction of critical events, or the projection of the energy demand and production. And for this, we have been using a software developed by our colleagues from Universidad de Girona that was providing the grid schedule to be deployed by the PET, the PED, and the batteries. When it comes to the quality service, we studied the voltage profile improvement and the critical event prevention, and we've been also testing island mode operation. So to do that, again, we've been using the PED and the batteries to smooth the voltage variations by exchanging power with the grid. So increasing or decreasing the voltage to compensate the variation of the consumption and generation. So after all this testing, and even though we are still finishing the last tests, we can conclude that this technology that we're developing with Resolve is improving indeed the operation of the grid, especially when it has a high presence of distributed generation. And it's exactly because of that it is also safe to say that the current renewables capacity in the grid can be increased, and with this improve the overall efficiency of the system. When it comes to results, it is essential to count on the balancing services and the power compensation that together with the storage can provide the optimal results we're looking for. And finally, the position of the batteries, it is really important to ensure that the energy that is generated on site, it's consumed locally. And that's important because then you can avoid the congestions in the grid that Kim was talking about before. So this is a brief, more technical presentation about the pilot. Thank you all for listening, and we'll be now happy, me and Ramon, to be answering or commenting any issues you may raise.
Thank you, Joanna. Thank you very much for, I think, a very comprehensive, but also a very, I think, relevant presentation. Before I think we go forward, I think it's very important to highlight what you were mentioning about connecting different type of storages using the technology like PED developed in Resolve. What I would like to maybe ask you is that how, from a distribution system operator, that is very important for you to not just rely on one particular type of technology, let's say lithium ion only, but you are free to use multiple type of storages with the power electronic devices that you can install. Can you please elaborate a bit more on that?
Sure. And that was the main aim of having different battery systems. And for sure, I guess in the future as well, we will be able to integrate developing technologies that are now still a bit underdeveloped, but for sure, having different resources improves all this deployment of the electronic devices in the distribution grid, for sure. Yes.
Yes, absolutely. And maybe one quick follow-up question. You mentioned about the storage location. I think for a distribution system operator, it's very important that you are able to locate and install it at the proper premises where it makes the most beneficial sense for the grid. So how Istabanel looked into that?
So since the pilot area, we had two different substations. We wanted to have it in one of the two, to have it close to the consume points, the supply points, and also the generation points, those PV installations that our clients have. So we located in one of the substations, also because of space reasons. We located in the bigger one. So that was the closer point to our consumption and generation points that we could get, and it's working fine so far. So I think we did right on that point.
Great, thank you very much, Joanna. Thank you so much for presentation. So we will move forward now with the rest of the agenda. But I think we have been listening to some really interesting talks, and now next up we will be listening about the different technologies. But before that, let's try to take a short break. So from my clock in Norway, I hope it's the same in the all Central European. We are at 9:31, so we will be back at 9:41 with the start of the rest of the discussion. So let's take a short break, and then we will hear from the technology providers. Hello, everyone. Welcome back. I hope you have been able to get some coffee and a bit more enthusiasm and motivation to now let us dive into all the key exploitable results and also the key innovations that were developed throughout the duration of the Resolve project. So we will have a 12 minutes presentation and a 3-minute question and answer session with each of the technology provider. With each of the presentation finishing or you are watching, please feel free to add your questions by using the Q&A tab of Zoom platform. So once we see the questions, we will try our experts to answer it. So without any further ado, I will start today's first presentation with the power electronic device that was already mentioned in the Stabanel presentation. And I would love to now give the floor to Francesco. Francesco, can you hear me? And can you please speak and we can hear you as well then?
Yes. Hello, good morning.
Good morning, Francisco. Thank you very much. Francisco, please, you can try to share your screen now, and then we can start off with the presentation about PED and why is it important and how UPC has developed it in the project.
Okay. Can you see the screen?
Yes, it has come up. Can you put it in the presentation mode? So then it's wider.
Perfect.
Perfect. Floor is yours, Francesco.
Thank you. Yes. Well, thanks for the presentation and welcome everybody to this event. I'm going to present one of the innovations of Resolve project, which is a hybrid energy storage solution called Power Electronics Device, or PED. This hybrid energy storage solution has been developed in the research center CITSEA UPC at the Technical University of Catalonia in Barcelona. At the CITSEA UPC, we are about 60 people working for more than 20 years on projects related to power electronics and their applications in different environments, like industry, renewables, smart grids, and energy storage. So in Resolve, I'm talking now about energy storage for renewables integration in electrical systems. What is the main problem tackled? Well, first, energy storage is a must. To integrate more and more renewables, batteries are to provide both energy and power-related services. Second, batteries are expensive, and their environmental impact should not be understated. And third, each battery type in the market, for instance, a lithium-ion or a lead-acid battery, is best suited for providing either energy or power-related services. There is no unique optimal battery type in the market for everything. So to sum up, we need a storage for the variety of user needs, but this is expensive, and there is no unique technology able to do everything in an optimal way. So how does the power electronics device mitigate the problems stated before? The answer is hybridization. So first, and thanks to the hybridization, so the combination of various battery types in a single solution, it is possible to optimally provide energy and power-related services to end users. And the stacking of services eases the economic feasibility of the project. And second, the hybridization permits to allocate part of the overall storage capacity in cheap batteries. So for instance, lead-acid ones, thus reducing the overall installed capacity cost in euro per kilowatt hour. And third, by simultaneously exploiting various battery types, it is possible to reduce the stress on each one, thus extending their lifespan. So to sum up, what we have is a power electronics cabinet that can integrate different battery types and exploit them simultaneously, following the set points to the end users, that in the case of Resolve project is a DSO. The power electronics device is offering services related to the power quality improvement, security of supply, renewables integration, and off-grid operation. So let's see a video showing how does it work.
Once upon a time, there was a little community connected to a secondary substation. As the day starts, the residents of the town wake up slowly. They are getting ready to face their long day. They use household appliances. Some will take a shower, others will prepare breakfast using the microwave and the coffee machine. Meanwhile, when the sun rises, the photovoltaic system installed in some households start to generate energy. As time passes, people start to leave home to go to work, attend school, or fulfill other duties. Today is going to be a sunny day, and therefore lots of renewable energy will be generated. The households will not use the self-generated electricity because they are empty during noon. Then the not consumed generated electricity is sent to other neighborhoods through the distribution system. This situation causes the distribution grid to stress, and in near future it could become more and more frequent. This is because the distribution grid was initially designed to feed customers and not to collect their generation outputs. During the noon, when the panels are simultaneously at their peak, the transformer of the low voltage grid can reach its limits and saturate. In this scenario, the voltage rise can even lead to overvoltage that might damage some electrical appliances. Now the sun is setting, but during the day a lot of electricity has been sent to the distribution grid. For some days the DSO has been thinking about how to solve the situation. Should the DSO upgrade the transformer, or maybe it would be better to create a new secondary substation? Perhaps there is another way to face these situations, some ways to involve prosumers and create a local energy community. Meanwhile, the residents are coming home and electricity demand rises again. But something is not going as expected. In households, electrical appliances do not function correctly. Washing machine vibrate, TV flicker. This seems to be due to power quality issues from the supply grid. Once the sun has set, household consumption increases even more. The DSO is worried. The transformer is again struggling to handle such high consumption. Once again, the transformer is overloaded, now due to the consumption of the households. Suddenly, when the demand is at its peak, a fault happens and interrupts the power supply, leaving all households in the dark. Time passes until the DSO emergency brigade shows up to repair the fault. This is inconvenient for the residents who have to stop their activities and go to sleep in the dark. Later, the fault is repaired and the grid can be finally restored. The DSO might have found a way to manage these situations correctly. A new and innovative asset is connected to the secondary substation at the low voltage grid. It is called the Powertronic device, PED. PED contains Powertronics, lead-acid battery, and lithium battery. A new day starts with the PED already operating. Slowly the residents wake up. They get ready to face a long day of work again, using household appliances, some taking a shower, others preparing breakfast. When the sun rises, the photovoltaic panels installed in some households start to produce energy. As time passes, people start to leave home to go to work, attend school, or to fulfill other duties. today is going to be a sunny day and therefore lots of renewable energy will be generated. However, instead of feeding to the grid, the energy is stored in the batteries of the PED. In this sense, the PED avoids the grid stress. Also, it is avoiding possible overvoltages and transformer saturation. Today, the battery will be fully charged at 100%. Now, it is needed to upgrade neither the transformer nor the low voltage grid. The residents are coming home again and the electricity demand rises again. They are using the energy generated by their solar panels stored in the batteries of the PED. Moreover, the PED has more capabilities. Acting as an active filter, the PED improves the power quality of the grid, avoiding power quality issues due to harmonics, imbalances or reactive power. Once the sun has set, household consumption increases again. In high consumption situations, PED supports the grid sharing the load. Unloading over voltages of the transformer. Suddenly, a fault interrupts the power supply. However, PED keeps energized the low voltage grid while the fault is waiting to be restored. Powertronic devises a hybrid storage solution for decarbonization of energy grids.
Okay. Well, so coming to an end in, well, I hope you can see my screen again. Coming to an end in Resolve project, the obtained results so far are around the following aspects. We work on the robustness by effectively integrating the cabinet in the secondary substation of the DSO. Then we work on the interoperability by setting up applications and communication channels to let the PED to be operated remotely from the DSO's SCADA. We work also on the characterization of electrical efficiency of the cabinet and the related power electronics modules, reaching, for instance, 98.5% of efficiency for individual inverters working at full power. We also came up with new operational strategies trying to take advantage of the modularity of the PED through further research in the future. And about batteries, we work also on batteries integration on field, dealing with many issues related to battery characteristics and limitations. For instance, the interoperability of batteries BMS with the power electronics, the self-discharge phenomena of cells, the testing methods to characterize energy storage capacity and efficiency, and the effect of the internal resistance of the batteries in the inner controllers of the power electronics. And finally, we are testing grid services. So far, we successfully operated the PED as a voltage source in the field, that is, feeding consumers directly from batteries, not with grid support. And we are also checking the performance of the PED while following the signals from optimization algorithms run by the partners of the consortium to increase the grid hosting capacity of renewables. So all previous activities and results made Resolve project as a great opportunity to advance in technology readiness level. Future steps are to further develop this technology, adding functionalities all around the concept of hybridization and modularity, and trying to further minimize storage cycle costs in Euro-kilowatt-hour cycle. The objective of this would be to make the hybrid storage solution closer to an industrialization level by potentially other energy storage developers. So thanks a lot for your attention.
Thank you. Thank you very much, Francesco. Thank you very much. I think it was a very interesting, the combination and of looking at what from an end user's point of view, how much it's important that we have these kind of innovations to have a stable system that we really, as an end user myself, is always sitting at home and getting electricity, but behind the scenes there are so much going on. So maybe one quick question that I think I would like to ask about the PED is that if there is a problem at certain point, you know, it's a technology, so it's a device that is running throughout the days, and then if there is a problem, somehow there is a fault in the device, then how does PED or have you been to deal with certain this kind of things?
Well, since we are in a development phase of the device, sometimes we have to go to the pilot to check that everything is correctly working. But for other issues, we have some local controllers and web services, so we can evaluate the status of the PD remotely from the university and correct some things about the software and about the set points for operating the PD.
Okay, perfect. Thank you, Francesco. I think we had one question, but it was, I think, already answered. It was about why did the lithium-ion batteries were connected with PED, but as you mentioned in the presentation, it was lead acid and lithium-ion together.
Mm-hmm. That's true. Yes.
Yeah.
There is a lithium-ion and a lead acid, and by adding a lead acid battery, we can save some costs because lithium-ion batteries are still expensive. So we can allocate part of the storage capacity in cheap batteries, and these are lithium-ion lead acid batteries.
And maybe just quickly on top of it, out of curiosity, were also second-hand life batteries were looked into if that could be an option?
And definitely, this is an option we want to explore beyond the Resolve project. This is an option, and so the hardware is prepared for that. So it's a question of mainly dealing with the BMS of these second life batteries from electrical vehicles.
Okay, perfect. Thank you, Francesco. Thank you very much. Very interesting, I think, discussion there. And with that, we can move forward to the next speaker. So we listen now to the PED and how important it is to deploy certain such technologies to integrate storage into the low voltage distribution networks. But now we will hear about the different sensing and advanced hardware devices that can be integrated into the system to gather the data and perform edge computing and things related to that. So with that, Miha, I hope you can hear me. Are you there? Can we hear from you? Yes, we can see you.
Yeah. Hi, Farhan. Hi, everyone. Good morning. Can you confirm you can hear me well?
Yes, we can hear you. You can try to put up your presentation. So Miha will be talking about the PMU and the edge computing and the smart gateway that Comsensus, the company, has developed during the project lifetime. So Miha, we can see your screen and it's perfect. So floor is yours.
Okay, good. So again, good morning, everyone. So it's really a pleasure to be here and to present you the results of the Resolve project. So as it was already announced by Farhan, so I'll be talking on the aspect of the grid observability and the edge computing services that we have established within this project in order to support the services that have been previously presented by Ioana and Francesco. But before that, let me just briefly introduce myself and the company. So I'm the CEO of the company, coming from the research domain, where we have funded the company as a spin-off from a public research institute, with the aim to actually work in the domain of cyber-physical systems, so designing embedded systems, hardware and software, managing the edge devices, and on top of such established infrastructure, instantiate the data analytics services. So coming from research, we are very much driven by the research and innovation, with a specific focus on the smart grid applications. But on top of this, we are strongly committed to capitalizing on the proof of concepts achieved in various projects, be it funded, be it industrial, in order to take the prototypes and the experiences from the pilots into the market, and to actually, together with the partners, design, certify, and commercialize specific solutions. And today I'll be talking about two specific things that we have achieved with strong support of Resolved, and the experiences from the pilots. So I won't be spending much time here on the motivation, because I don't think it's necessary for the audience, because I think we understand well, I mean, what's the motivation for the applications that we are building. But still, so where are we according to, I mean, how we see it as a company? So, I mean, having a DSO as a customer, so we see that there are a lot of complex custom solutions that are being used for dedicated applications. And there is a certain level of integration, but this is still to happen, to be really exploited in terms of all the data that we dispose with. So the situation is that, I mean, the core of the network, so the SCADA, it's for sure digitized. And I mean, the recent years have shown good progress in the deployment of smart meters, which is, I mean, from the grid perspective, could be called as the far edge. But on the cross section, so going from medium to low voltage, which is also the focus of the Resolve project, so the digitization is still to take place. And our aim in this respect, with the observability in order to support the operation of the services, is to actually introduce the flexible edge solutions that can be, on one hand, integrated with the legacy environments, and on the other hand, support new disruptive applications driven by the trends that are taking place in the distribution segment of the grid. So the introduction of distributed energy resources, so the proliferation of electric mobility, and similar things that we are observing. So, I mean, yeah, the bold ambition is for sure to introduce the one-size-fits-all solution that would allow the real-time measurements in the edge, that would support the management of these devices and allow for reliable and secure connectivity. And last but not least, that it would allow the operation of distributed services in an autonomous manner. So how did we do this in Resolved, and what are actually the main technology building blocks that we are taking out of Resolved into further exploitation? So first, I would like to present you the two results that are linked to the metrology, so to the grid observability devices that we implemented within the Resolved. So the first one on the left-hand side of the slide is the phasor measurement unit, which supports the functionalities of synchronous real-time measurements of the grid in terms of voltage and current synchrophasors, the estimation of the frequency, the rate of change of the frequency, and other parameters as defined by the respective standards, C37, and allowing, as also requested by the standards, so the redundant connectivity and supporting various time synchronization interfaces. I'm very happy to actually announce here that actually using the results of the Resolve and within the project also partnering with the industrial partner, we have actually managed to bring the device up to the level of the fully certified device for the installation in the grid. That is actually compliant with the here listed directives, which we have tested according to the also listed standards here. I'll show the use case of this device that has also been explored within the Resolved in the next slide. But just before that, let me also mention the other device, which is the power quality monitor that was implemented as like the power quality measurement device with the capability of actually embedding and running in the edge also so like constrained services in order to allow for the connection of the distributed energy resource directly on this device, and with also the downstream connectivity allowing for a certain level of control of such device. So given that this device is also, targeted for the segment of the edge grid, it embeds the cellular network connectivity and supports the legacy standard of Modbus for the interconnection of legacy equipment. And this device has been used actually also in the pilot to observe the conditions on the grid and the particular contributions of different segments of the grid to the whole situation. So having this infrastructure elements, and the ambition to run the services in the edge, so our idea was to implement the pilot setup as it is depicted on this picture. We'll not go into details about that, but what I want to just share with you today is that in this pilot, so the phasor measurement unit is connected to the local data concentrator, which actually runs the service of grid disturbance events detection, and then with the use of the gateway functionalities forwards this into the centralized decision system that's implemented in the cloud. And similarly, so the PQM embeds the gateway functionality in order to allow for the observability in particular buses. And the application that we have implemented with such formed architecture was to actually first enable the real-time observability, and then based on this data, so to actually process in real time in the edge the sensed potential disturbance events, feed those into the historian database for models training, and then from the relevant events to actually constitute reports in terms of the time when the event happened, the location that was calculated to be the location of the event, the snapshot of the data, and the description that comes from the classification. So, so as you can see here, so the application is implemented. So from the combination of the edge, the cloud, and then the reporting system to the operator. And now I want to show you a few results. So just a glimpse of what we implemented and what we have been able to actually get from the pilot. So the focus here was on the observability of the medium voltage line and all the cross sections between the medium and low voltage, with the PMUs installed on both ends of this medium voltage line, and the PQMs installed on all the buses along this line. So the fault or disturbance detection scheme was implemented in the way of a model-driven approach. So knowing upfront the topology and current configuration of the grid, the line parameters, and the real-time estimation of the loads measured by the PQMs. And on the next slides, what I want to show you is like the two events that we have sensed in the 20 kilowatt ungrounded infrastructure, which actually focuses on the detection of these events, so classification, whether these are temporary or permanent faults, and to the identification of a bus in order to then trigger the actions for the service recovery. So what I'm showing here are first the examples of the temporary fault that has been sensed. So it was the case of the one-phase ground short circuit fault. And what you can see on the slides on the left-hand side are the measurements of voltages and currents in the primary substation. And on the right-hand side, you can see the voltages and currents measured in the secondary substation. So the fault happened at these cases of the glitches in the voltage and current measurements, where you can see that actually after the fault happened, the currents fall to zero, and the protection of the grid starts to act. If we just look at the close-up of this event, which is this segment, so what we can see is that so the fault happened on the line B, which is demarked here with green, and that the protection actually was automatically actuated, and then the reclosure was actually instantiated half a second after that. It was not successful because the temporary event has not yet phased out. But then going back here, so after 30 seconds, which is the second glitch that you can see here. So the grid service was restored. This is which happens here. This is the first example, and then in the second one I want to show you. So okay, after we sense that the certain event it's relevant and that it is a permanent, which is the case here. Here we actually instantiate the services that were developed by Resolved in order to gradually recover the service in the network. So a very similar event sensed here, going into the close-up of this segment, which is noted with red. What we can see is that so the fault was permanent because neither of the reclosures from the protection actually managed to restore the grid. But what we can see is that after this time, after 3 automatic aims for the restoration, so the operators managed to actually restore the service by the reconfiguration, which is demarked here with the restoration of the service in the part of the network. So this information was actually gathered from this very short events happening within a couple of seconds period, from which we actually are able to understand on the type of the event and estimate the location, which actually then provides the information for the grid reconfiguration. So this is just an example. I don't want to go more into details, but want to conclude this presentation of initial results with our exploitation pathway, which actually relates to what I have presented before as our strategy and the way of work. So we are actually running the replications and advancements of pilots in different parts of Europe and also as of recently in South America, focusing on the actually events classification, the procedures for the grid reconfiguration, and also for using the instruments in order to support the controlled islanding and the reconnection to the main grid. On the gateway part, we are actually integrating and allowing for the interoperability with other controllable assets like charging station, heat pump, and inverter. And this is actually a follow-up work that we are doing in some funded and also industry projects. So again, I mean, our idea is to partner with the industry, which is the either producers of the equipment, either system integrators, in a vision of offering follow-up turnkey solutions for this very interesting market segment. With this, I'm concluding the presentation and of course will be available through the event for some questions.
Thank you, Miha. Thank you very much for such a nice presentation and also highlighting very relevant cases that happened during the piloting. And maybe just a quick question that I could maybe ask you before we move on to next speaker is about you mentioned about partnering up with the other organizations. And could you tell a bit more about how does that consensus point of view look like? So you basically first discuss a bit of possibilities that are there or applications that these devices of consensus could go forward, and then you follow up with the pilot, or how does it look like?
Well, what we try to achieve, I mean, also within the funded projects that I mentioned, is to really benefit from the pilots and to actually partner with the industry already within the framework of the projects in order for the ideas to clarify and to gain initial results in the project. Then the follow-up is actually given this initial experiences and so the better knowledge of the market needs is to actually try to find industrial partners in order to actually introduce on the market not only a component but a complete solution. So just to give an example on the PMU, so we did not partner with the company producing hardware. However, we partnered with a company that has a software solution for the WAMs. And now together we actually have so the infrastructure elements, which is the devices, and also the software, which allows us to build new services that can be migrated between the cloud and the edge. So this is the vision that we are implementing.
Move on to next speaker. We already heard from Quim previously as a project coordinator, but now we will talk a bit more about how the University of Girona basically worked on developing this low voltage distribution decision support toolkit. So with that, Quim, again, welcome. And then please, can you try to share your screen? We will de-share from our side, and please take us forward with your presentation.
Yes.
Perfect.
Now you can see it.
Screen, can you put it in the presentation mode, maybe? And yes, now it's perfect. Floor is yours, Quim.
Thank you, Farhan. Yes, so now I'm presenting this set of services, this low voltage distribution support toolkit we developed at the University of Girona as part of this Resolved project, and trying to introduce or to provide with certain intelligence to the whole system. Okay. Just to say that we are a research group. EXIT is the acronym from Control Engineering and Intelligent Systems. This is a research group at the University of Girona. We are around 20 people, and we can divide in 3 groups. One is the academic people, the staff people that we teach also in the Escola Politécnica Superior. So we are in charge of teaching electrical engineering, artificial intelligence, and automation, depending on the profiles we have. And also we do research at the Institute of Informatica and Applications. And the rest of the group, they are 1/3 postdocs and 1/3 technicians and PhD students. So this is our group. And the motivation of this group is developing applications or solutions based on artificial intelligence principles. Mainly we are focused on the exploitation of data, so providing data-driven solutions, and focusing in providing solutions for decision-making in the energy sector. Okay, so in this case, it's an application for the smart grids, but also we can work with communities or with buildings, providing this kind of solutions. Okay, so in this case, I like to present this toolkit. This is a set of services, a set of algorithms now fully integrated in the Resolve solutions that we develop with these 2 specific goals. First, to improve the observability of the low voltage grid, and second, to support the operation of this grid, okay, based on the information that the instruments and the observability algorithms provide. So the tools basically are one tool for energy forecasting. It means forecasting of energy and demand. This operates from data coming from the smart meters. And based on this data, based on the forecast we do on this data, we also forecast the possible critical events. This means the possible congestions in the grid and variations on the voltage that can be over the limits or can damage the devices connected to it. Then another set of tools, or another tool, is those devoted to fault detection. This is a tool that basically manages data from the PMU, so it goes with with a high sample rate, and provides informs about detects about possible faults in the grid and informs the DSO about these events. And based on these outputs that the previous tools gives, then we provide a couple of optimization algorithms. This is enclosed to this grid operation scheduler tool that provides, on one hand, the management or the schedule of switch gears in the grid to avoid critical events, and also it manages energy by scheduling the charge and discharge set points of the batteries also installed in the grid. Okay, so we manage as an input these data sources from the PMUs, from smart meters, from the SCADA. And as output, we give schedules, we give orders to the batteries through the PED, through the power electronics presented by the UPC. And also we can give orders to the switchgear installed in the grid. Okay. So this means that the services, in fact, are software and they are integrated with the legacy systems. And this integration has been done by using the ESB and the solution that Icon will present after. Just going a little bit insight on these tools, the energy forecasting toolkit has these two capabilities of forecasting demand and generation. For the demand, we use data from a smart meter, so they can be adapted to the granularity they offer. So it means working hourly or with 15-minute resolution, it doesn't matter. Then we can also provide the forecasting for each device, but we prefer to do aggregations at the bus node where they are connected just to improve the resolution, the accuracy of the methods. And the training requirements for doing these forecasting models are just working with 3 months of data. So we are retraining just to adapt to the seasonality, and we work also with the information from calendar and weather. For forecasting, in this case, we only focus on the PV, and we use simple models. And what we do to improve the accuracy is to adapt according to the errors we are getting. We adjust the gain of the models just to adapt to the seasonality. Okay. The second, based on the information that we get from these forecasting algorithms, that we combine these outputs with the power flow solver, and we do this just to forecast possible events. These events that we mentioned before, these are possible congestion, so currents on the lines that goes over specific thresholds, and also we detect possible over voltages in the grid. And we give information about the position, about the location, and about the possible time according to forecasting. Once we detect this possible forecast, or we forecast, these critical events, then we can launch the critical event prevention. And this is just an optimization algorithm that tries to solve the best configuration of the grid on the basis that we have this possible switchgear or this possible operation switches. And we provide a schedule based on the statement that we have to do the minimum set of operations to get these situations and maintain this safety situation. For this, we manage with a particle swarm algorithm. Next, the next set of algorithms is focused on fault detection, and here we change the data sources. In this case, we manage data from PMUs. So again, we need this interface that the ESB, the ICOM solution provides by collecting data from all the sources, in this case by collecting data from PMU, and they invoke all our algorithms. And these algorithms are based on the statistical methodology. So we set a model based on the normal operating conditions. And then what we do is to detect change from a statistical sense. Okay. And these are associated to these faults. that then are informed through the platform to the SCADA system. Okay. In this case, the system, since we said that the grid has possible configurations, this algorithm or this application has the ability to train models for all different situations, so we can manage this change on the grid configurations. And it's difficult to test this solution, so what we did is to perform several changes on the load of the pilot scenarios, and then with these faults or with these simulated faults, we check the accuracy of the system, reaching this 97% of accuracy. Just mention that this works with, since the PMU has a very high resolution, what we do is, instead of evaluating every sample at every time instant, what we work with windows of data, but we evaluate all of the data that is being produced by the PMUs. So the accuracy of the fault resolution, the fault detection resolution is very high, and maybe we have a delay due to this sliding window in the evaluation. Next, once I said before that when we detect or we forecast these possible critical events, we do a planification of the grid configuration. This is for these special cases. But when the grid is operating under normal conditions, and we have these prosumers that has the PVB connected to the grid, and they are producing excess of production, or they have peaks on the consumption. So this, what we try to do is with this algorithm, with this operation scheduler algorithm, is to manage the batteries that that are installed in the secondary substations. And what we do is, by considering the forecasting of energy and demand, we calculate the optimal schedule of the charge and discharge set points for the batteries, and then we send this schedule to the PED, also through the platform, the Resolve platform, and the PED is the one that executes this schedule. In this case, the goal we pursue with these algorithms is to increase the local consumption of the renewable. So this is one of the objectives we try to achieve, and also to reduce the peaks. No? Not only consume renewable energy at the locally produced, but also to reduce the peaks in the demand. So this means you could see in the graph on the right. This is the blue curve is the demand curve expected based on the forecasting of the generation and demand, and the red one is the one we generate after executing the schedule. So we flatten the curve and we avoid sending energy to the main grid through the substation. In this case, we avoid the exportation of energy, and we get this reduction of around 18–19% on the demand curve. Just mention that all of these tools, these algorithms, have been developed as web services. So they are running in a server in the cloud, and they are, in this case, fully integrated through the Resolve platform. It means that through the ESB, through the solution that ICOM has provided, it's possible to invoke the algorithms, and based on the outputs of these algorithms, we create different applications. For example, the critical event prevention application, the loss reduction application, and similar applications could be conformed based on different calls of these algorithms. Now the solution is fully integrated with the Resolve platform, but it could be also offered as separate services. And just mention that is integrated together with the legacy system. So we manage data from the MDMS, so from the metering infrastructure. We manage data from the PMUs, and we manage data from the power electronics device, to know the state of charge of the batteries. And also we are capable to send these set points to the batteries, and we are capable to send the set points to the switchgears through the SCADA system. That's all from my side. So thank you. And if there is any question, I would like to answer it and discuss with you.
Thank you, Koim. Thank you very much for the presentation. And I think you already mentioned quite a interesting next steps through exploitation pathway. So maybe quickly you can comment about how does this solution of UDG could be then taken in the next exploitation method? Would it be a license agreement, or how does it look like?
Yes, this is software. So software, it's we don't have a patent or similar like that, a similar solution like that. So for us, the more convenient solution is to adjust or to adapt the solution to the necessities of a specific customer, and then yes, exploit using some kind of agreement or licensing of like this in the software. Thinking that this can be implemented as this strategy of software as a service. So based on this concept, we are open to different strategies for the exploitation.
Okay, great. Thank you, Koim. Thank you very much for a very nice presentation. So with that, we can move forward to the next speaker. So we discussed about software and we discussed about the hardwares that are needed now to make sure that we have a very smooth system that everyone can look and operate. But one of the challenges is always security. And this is where I think we have our partners from Johannam Research who worked a bit on the cybersecurity methodology. And Heribert, I see you there. Can you hear me? And can you speak a bit so that we can hear you as well?
Yes, just a moment. I will share the presentation.
Yes, we will de-share and you can try to share your presentation from your end. So Heribert will be presenting the cybersecurity methodology from Johannam Research. Heribert, we see your screen, so can you please put it in the presentation mode?
Yes.
You are now showing, the other one, so you can just change the switch this one. Yeah. Yes.
Okay. Can you see it now?
That's good, and floor is yours, Heribert.
Okay, thanks. Well, hello, my name is Heribert Walland. I work at Johannam Research, which is a research organization in Austria, and we are doing mainly applied research projects. The company is owned by the public, and we have 3 owners, the local government of Styria, Carinthia, and Burgenland. Therefore, Johannam Research plays a key role in facilitating the technology and knowledge transfer to these regions. Johannam Research has 7 research units covering areas like materials, robotic, health, climate, and I am from the Institute Digital, the Institute for Information and Communication Technologies. It's the largest institute at JTR. At the research group on cybersecurity and defense, our research topics are cybersecurity modeling, also formal verification at the area of cybersecurity, and AI-based detection of cyber attacks. Well, Johannam Research is responsible, as already mentioned, for cybersecurity within Resolved, and the ongoing transformation of the electrical energy grid from the classical unidirectional generation consumption schema to a fully digitized, bidirectional, decentralized energy system with different players having different goals. If you think on generator, aggregators, prosumers, retailers, this involves technical, organizational, safety and security and privacy issues. Especially new intelligent algorithms in the smart grid and the proliferation of the internet protocol makes control devices vulnerable to a broad range of security issues known from the IT world. So nowadays we have the OT convergence, where the historical air-gapped OT systems are now more and more accessible online. So as you know, for example, the Ukraine, for example, was struck by a large-scale cyber attack on their power distribution system causing a complete blackout event. This blackout affected approximately or more than 200,000 customers. And if you look at the scenario there, it is similar than to other scenarios at the industrial control systems in a smart manufacturing. So you have a phishing email, then a compromised Word document, and then via this they got the credential of the Office network. And then when an attacker is in a network, then he normally moves from one machine to another machine. So this lateral movement. And then they found a machine where there was a VPN tunnel to the OT system. And so they were there, and then they manipulated the gateways of this OT network with a compromised firmware, and they were able to perform a SCADA hijacking. And also what they did, they obfuscate their attack, so they deleted boot records and also removed log files. So it was very hard to figure out how they did it. Okay, yes. Designing security in cyber-physical systems from the beginning on is the most cost-effective way, since it minimizes risk and also financial expenses. Our approach in Resolved is aligned to the Microsoft trustworthy computer security development lifecycle. This is a software development process also used by Microsoft and also proposed by them to reduce maintenance cost and increase the reliability of the software with regard to security issues. Here you have a classical spiral model where you have the requirements phase, but here the identification is of the security requirements and the protection goals of the software components are in focus. So then the next phase is the design phase, where you identify building blocks which are essential for security. Then during the implementation, you use the libraries and tools to perform a secure implementation, and also the verification is a very important part, because here you make a systematic check for security flaws. Here the two other phases, deployment, support, and service, but in Resolved we concentrated on the first four because we are a research and innovation. Resolved is a research and innovation action. Okay, let's move on to the security approach within Resolved. The starting point was the data flow diagram of the Resolved system architecture, which in turn was based on the results of the SCAM interoperability modeling, and also based on a proposal for a list of security measures for smart grids from ENISA, and together from a national funded project here in Austria called Risk Analysis for Information Systems of the Electricity Industry. A list of applicable threats were identified. The next step we performed was a risk assessment of the individual components. Therefore, each partner assessed the risk of their technology they are in charge, and we got a risk assessment with the probability of an attack and also the impact of such an attack. This was then used for the threat modeling process. For this, we used the Microsoft threat modeling tool, which on one hand has already default templates that provides corresponding security features of processes, devices, data, and communication channels widely used at the IT domain. But since Resolved is in a different domain, in the energy domain, so here are different protocols and components are used, and we analyzed these protocols and extended this template from Microsoft. And the output of this was a list of threats. And if you know the threats, then the requirements are for sure you have to mitigate these issues. Okay, let's move on to the design step. Security building blocks are measures that can be applied to the devices, application, protocol, communication channels in order to function in a secure way and to mitigate these identified threats. So a security building block could, for example, device security. So you have to disable all unnecessary network connection, all unnecessary ports. You have to disable unneeded system accounts and to have to change default credentials and so on. Also, cryptographically measures are such a security building blocks. If you use them properly, then they are one of the strongest possibilities for securing different things like data or connections. Well, if you now have these different security blocks, but not all of them might be applicable because components maybe have some specific constraints. So these constraints, for example, could be the bandwidth, the computing power, the memory, communication protocols that can be used, also operating system. So for each individual component of the resolved system, these constraints were captured and analyzed. And well, we can say that the review of these constraints has shown that the computing intensive operations for state-of-the-art algorithms can be handled by all components within Resolved. And based on this, we retrieved individual implementation guidelines for the Resolved components. They are also documented, and this document can be downloaded at the Resolved webpage. Yes, and finally, you have to check the security measures. And for this, there are a lot of tools available, but it is also very important that you have experienced specialists that are needed, because not all of the security flaws can be detected automatically. Yes, I want to mention that security is an ongoing process. So it's not possible to 100% secure such a complex system. There are always risks that has to be handled. So in the prevention phase, you have to identify these risks, and you have to do the protection. You have to place detections system on it, and then if something happens, you have to respond very quickly. Well, the drivers of this risk, let's say the energy domain is the huge surface across the whole value chain, because as you know, there is this distributed energy generation with different participants. You have the prosumers, you have the aggregators, the retailers, and all of them can introduce new threats to the system. Also the IT convergence I also mentioned, and also cross-sector coupling, power to gas, or also the interconnection with the heating grid are also potential risk to the system. Also, the introduction of industrial IoT or IoT opens new threats to the systems in place, because every component can change the whole security risk. Also, new regulations and business models have to be addressed, and also various type of attackers are performing the attack. So from the now to the conclusion, the security by design approach is a very valuable approach and helps to minimize risks, very effective, but it has also some pitfalls. So pitfalls, for example, implementation, integration, and during the deployment. So we figured out that we have these guidelines, but when something is implemented, yes, there are also some failures which were introduced. So we got information disclosure by default pages. Also, third-party libraries were used with different vulnerabilities. Weak transport layer security, cipher suits were used. Also, password policy was not optimal. Also, yes, we found a lot of things, and here I want to emphasize that it is very important that security checks have to be performed periodically. So which have the benefit if, for example, a feature is already developed, so don't only test the functionality of the feature, you also have to test the security of the feature. And this would be a benefit also for the developer, because he get then feedback from the security tester very early, and he could improve it, and the next time he will consider this from the beginning on. Yes, and I want to emphasize once again that this is an ongoing process, and yes, security is an ongoing process. Well, yes, that's all from my side. Thank you.
Thank you very much, Heribert. Thank you so much for your presentation, and I think emphasizing that it's an ongoing process highlights, I think, that it's something that everybody nowadays, especially with this pandemic and everything going so much digital, that how much is it important. So maybe just a quick question there would be then how Johannem Research could offer this kind of ongoing process of cybersecurity methodology to other people who would need it.
Yes, we could offer this as a service to other people, other domains, because we have here this threat modeling approach with components, and this can be offered to them so that they can see these threats, and also regarding penetration testing, and so we could offer companies in that way.
Perfect. Thank you, Heribert. We are running really tight on the schedule, but really thank you for your nice presentation and then highlighting the importance of security aspects. So I think with that we can move forward now to the next part of our discussion or today's event, and I think that's now we are building towards the part of how we can put all this together in one system. And then that's where integration and middleware systems are really important. With that, so Isidorus, I hope you are there. Can you turn on your camera or also your microphone?
Hello.
Hi, Isidorus.
Hello.
Yes, we can hear you, so you can try to share your screen. So Isidorus will be sharing us about the enterprise service bus, the solution of integration middleware by Intra Telecom. So Isidorus, we see your screen, and now can you put it in the presentation mode? Yes. Okay,
Great.
perfect. So Isidorus, floor is yours, and thank you.
Thank you, Farhan. So this presentation is about the integration middleware and what was devised from the infant, let's say, steps of the project to enable plugging in all the different components of the architecture, but also how it evolved to design a solution that will package this and consider extensibility aspects, reusability aspects, and usability from the perspective of the TSO. Just a few words about me. I'm an electrical and computer engineer, graduated from NTUA Athens. I've been with Intracom Telecom since 2015 and participating in research and innovation project under the umbrella of Smart Grids. Involved mostly in the technical analysis, design, and implementation of software solutions in the domain. Also, a few words about Intracom Telecom. So we are a global telecommunication systems and solution vendor operating more than 40 years in the market. We are also engaged in the smart grid domain and offering turnkey solutions, for instance, to distribution system operators, such as for metering infrastructure, AMI. Sorry, Herbert, we can hear you. And we're also actively engaged in research and innovation activities, either through national or EU funding, but also with close cooperation with domain stakeholders. And moving on to what's the challenge. So essentially, what's described here is that we have different solutions, individual offerings from Resolved and also from traditional solutions for monitoring the grid. And we also have this novel controllability, controllable assets, the PED, incorporating the storage. And we want to leverage these solutions at the level of the control center of the DSO, whilst considering the integration complexity and costs. What's more, we also, traditionally DSOs do not use such assets, storage assets in the grid. So moving on to the solution space, what we offer as a result of project, right, is that we can leverage all these different technologies and optimize the operation of the grids. It was the solution presented previously by Kim from the UDG's toolkit. So considering the different optimization objectives, whether it's preventing a critical event such as congestion in the grid or reducing the technical losses, we want to enable this information flow towards this operation and also enable the dispatch of the schedule that will leverage the controllable assets in the grid. So we can do this through the integration middleware, which will enable the flow from legacy systems such as the meter data management system or the SCADA or the GIS. And what's more, we need to enable the operator to have an overview of what's happening in the grid and intervene if needed. So a few words on the architecture. It was briefly presented in other presentation, but just as a trying to elaborate more on how the solution will plug with existing systems of the DSO. We have legacy systems such as the SCADA and the VMDMS GIS, as mentioned previously. These communicate with field devices, switchgear, sensors, or smart meters. And we have some high-level overview from the DMS, from the distribution management system. Now we have the PED that will communicate through the remote terminal units. The PEDs could be located in the substation level, as happens in the Resolve pilot, but also could be a customer premises level, with the WAMs that will provide cyclophasor measurements or power quality measurements. And all this the flow of this information can be enabled through the middleware, mentioned here as the enterprise service bus. And also accessibility to the data can be provided by the data management system, which we'll see later on features. So we have the solutions also of UDG providing analysis of grid events such as faults, congestions, also the production and consumption forecasting and the optimization, let's say, algorithms for dispatching of the assets to optimize the operation of the grid and tackle different situations that might occur. And finally, we have the user interface, the application that will enable the operator to monitor and control what's happening with regards to this novel offering. We also have integration of external services such as weather data. So moving on to the features of the integration middleware, what we offer is a mediation of the data, transformation of different protocols, enabling the communication among the different components of the architecture. We introduced, where possible, loose coupling among the application for enabling scalability and extensibility. And via the use of domain standards, we try to address interoperability, try to make the solution follow the best practices, even if this was creating more, let's say, an overhead for us. We try to follow the common information model, the IEC standard series, the CGMES, the model for the grid, for the models by the ENTSO-E. We provided secure interfaces and monitoring capabilities, and of course the automation of the orchestration of the different services that are part of this distributed, let's say, ecosystem. With regards to data management, we offered the coupling of the legacy systems, the SCADA or the MDMS. So we enable access to the data with specific quality of service characteristics and reduce the overhead for this production, let's say, level systems of the DSO. We use the graph database for the representing the CIM network models in the native format and enabling querying and modifying the grid in the native form, as well as the distributed storage solution for better scalability and performance and availability. Moving on to the user interface. So we provided a web application that will present the events detected by the algorithms of UDG, such as faults and congestions and islanding situations. And also presented the schedules calculated by the optimization algorithms. Also, a fine-grained analysis of the state, let's say, the state estimation of the different grid elements at the level of line, buses, and an assessment of what would be the impact of this grid actuation actions. And finally, the means to cancel, let's say, a specific operation and recalculate the dispatch of the assets. So having, again, a top-level view of how we plug everything together. So what we need is deploying the software solution, the middleware solution, the different services, the management system, the web applications for the user interface. We need to plug this, the SCADA, the MDMS, the GIS, and we also need the installation of these novel technologies for monitoring and controlling the grid, such as the WAMS, PMU, PM, and the PD. And what we can do is detect the grid events, the possible grid events, analyze them, dispatch mitigation actions, and evaluate the impact. So what is the competitive advantage of this solution? We discussed about following domain standard. ESGAM was referenced as a key standards for during the initial design phase. We also discussed about CIM and how it provided the basis for information modeling for extending, let's say, for tackling interoperability. Heribert in the previous session provided a very good analysis of how we treated cybersecurity concerns and how we make sure that we safeguard the operation of our solution. We discussed about extensibility and how through standard interfaces and the protocols we can introduce novel, let's say, new services. And essentially, I think this, let's say, more or less clear of today's presentation is how we can utilize the storage as an asset for the active network management of the distribution grids, which is not the traditional offering now in the market. A few words on exploitation, and this is, let's say, packaging the whole solution. So we need further experiences in other DSO case studies. We need to mature the existing solution. And we need to evolve. We need to introduce flexibility as a concept, as a flexibility markets, other stakeholders such as the aggregator, perhaps, introduce the EV assets, and also provide perhaps better automation with regards to integration with the existing systems of the DSO, for instance, for the switchgear automation, which is now performed manually. Like we provide the schedule, the preferred schedule, the suggested schedule, and the control is done manually. So some of these aspects are tackled in, let's say, a follow-up project, Fever, where many participants are involved from Resolved. It's also a Horizon 2020 project. So I hope I didn't burn much of my time because I have also a short demo. So there's a screencast that it's, sorry, what's this? Just a moment. I have a screencast that I need to stop sharing now and share this other application. Just a moment, please. So this is only some scenes because I want to reduce the time with regards to this presentation. So here we have a login screen, and now we will log into the operation of the application of the operator. So first we see a map of the different assets in the grid. For the pilot area, we have a legend here on the right where you can see all the different symbols, what they mean, the transformer, the consumer boxes, the PED, the switchgear, different lines and nodes. So by nodes, we mean the intersection between lines, the connection among lines. We can show hide different layers in the design, and by hovering on the different assets, we can see the relevant information such as installed capacity, nominal values, and the likes. For connectors, we can see what assets they interconnect. We can query for a specific, let's say, asset in the grid and zoom in to this asset. So more or less, this summarizes the map view of assets. So moving on to the events, the grid events. So we have a list on the bottom that pops out, and you can see the different events detected by the UDG's, let's say, tools, whether it's congestions in the grid, faults, over voltages, under voltages. We have different information related to this, such as what elements are affected, the severity of the event as assessed by the some rules that we have devised, and you can filter this list of events, and you can sort it and better analyze the daily. Let's say this happens on a daily manner. So for here specifically, we see the 18th of the month and what events were detected in this certain occasion. So how we visualize these events on the map, we can see this bar on the left where you can scroll and see for each time of day, it's in hardly half-hour interval, what events happen in the grid. And you can also simulate the full day. Moving on to the optimization and how the schedule is considered in this application, we see here the battery set of charge as it was scheduled from 11 in the morning for the rest of the day, for the specific day of February. And the actual measurements on how the PED followed this set point. So and we can also monitor the energy versus the state of charge. So we have these two different attributes monitored. We can also see the different switchgear and how the status is scheduled or actually measured. So again, the schedule begins at 11 o'clock, and we have the different asset statuses. Now, the state estimation of the grid based on the forecasts performed by UDG and the power flow analysis. So for the different assets, we can click and from the right, a new window pops, a new sub-window pops that you can see the voltage. In the case of lines, you can see the current values. In the case of nodes, you can see the voltage values for the different times of day. And moving on, we can see the overall status. So here on the left, we can see how the number of events detected for this day, and also specific metrics related to power flow reduction, power losses reduction, peak reduction, or imported and exported energy measurements. Finally, we see how we can manually cancel a daily dispatch. So during the piloting, the calculation happens on a day ahead basis. So we calculate the schedule for the next day, but you can cancel this manually through this button, and you can see now that the scheduled set point stops at 5 o'clock, for instance, here on the right. It doesn't. The rest of the set points were deleted. The PED will get let's say zero command, zero set point for the rest of the day, and through the reschedule recalculate button, you can request for a new calculation. Now this might take some time because they need to calculate again the forecast for the rest of the day, request for the optimization algorithm to perform an analysis. Yeah, so now you see that for the rest of the day, you have again new set points that will be dispatched to the battery. So more or less, this concludes the presentation on this session. I'm happy to answer any questions if you have any.
Thank you, Isidorus, for the presentation and for the demo. I think it was pretty comprehensive, and it's very nice to even hear and also feel it, that how does it actually look like in the final stages of the project. So I think we will have to skip to a next presenter to keep on the time. But thank you, Isidorus.
Okay,
and we will have the day 2 also of the event, where we will have more, I think, bilateral discussions on this very tool. So thank you, Isidorus. And now I think before we go to the break, before that, I think it's important to also look a bit more perspective that Resolve Consortium worked on is standardization and regulation. And for this, Professor Samper from Polytechnic de Catalunya has produced a white paper. So Andreas, if you can hear me, and also if you can see you. Hello, yes, we can hear you, but we cannot see you.
Yeah, okay.
Yeah.
I'll switch the camera on. So, okay.
Yes,
hello.
Perfect. Now we can hear you and also see you. So very, very good. Maybe you can share your screen.
Yeah, will do so.
Yes, perfect. So Professor Samper will be sharing with us some of the insights about the white paper that was published about standardization and regulation, on how these innovations can be then integrated in our society. So we see your presentation. Andreas, can you put it in the presentation mode maybe, or
Sure.
enlarge it a bit?
So,
yes.
Okay.
So, floor is yours, Andreas. Thank you.
Thank you very much. So I will present myself a little bit. So I'm Andreas Humper. I'm food professor at the Universitat Politècnica de Catalunya, UPC, we are partners at with this project. In this project, and we were mainly responsible for the development of the PED, which is the Powertronic device, but also we had an interesting task to coordinate a white paper on contributions on the H2020 Resolve project to standardization and regulation. So, I will explain you a little bit. The idea here is to explain you a little bit, or to summarize a little bit the white paper we produced. And well, it is a collaboration of several partners within the project, and we produced this white paper, and it contains significant insights of the Resolve project as first the needs and expectations in the involved stakeholders, the Resolve technology, both the hardware solution as well as the software solution, the existing upcoming regulation initiatives are presented, and the project recommendations to standardization and regulatory bodies are provided. So this white paper is available on the web page, so you can download it. It's for sure, it's for free. It's probably a nice document, that summarize not only the project results, but also some side aspects that are very important, are part of the technology. So, for sure, I will not go into very detail in the Resolve technology, because we had the whole morning presentations on that. So I will more focus about the stakeholder needs and expectations, regulation and standardization. So how we produced this white paper, we followed the following methodology. We identified the stakeholders. We made interviews of the stakeholders. Here we had the help of GEODE, which is the organization of distribution companies, small distribution companies in Europe. So we made a regulation analysis, in particular of the E-directive and E-regulation, made the analysis of the key outcomes of the regulation needs. And then we made the analysis of the standardization needs of the project. So, well, let's go straight to the key outcomes of the interviews. So here there's a general agreement within the DSOs and the regulatory bodies that we interviewed that that solutions to manage low voltage grid actively are needed. This is a very general need identified. And also we had the impression, or some interviewers viewers stated that investment are expected to happen at least the medium voltage level. So here, one point the stakeholders identify as that the capital expenditure friendly regulation, as opposed to the operational expenditure friendly one, is a significant barrier for the investment in smart technologies. We'll go back to this point later when we analyze the regulation. Well, also the stakeholders told us that flexibility services are effective in managing the grid. It is expected that the battery solutions will provide a very lucrative option in the next 2 to 5 years. Reactive power management is also a relevant issue. And when it comes to business models for smart technologies, including storage, there all stakeholders had a very, very different view. So this is probably a very open issue still. So, well, let's go a little bit on to the regulation analysis we made here. We focused on the clean energy package. You probably know that we have the EU directive and the EU regulation. Well, the clean energy package sees flexibility markets as vital to promote the widespread of new agents and technologies in the energy sector. One important point here is flexibility is important. We know this is the new backbone. So, but what it is very important is that distribution system operator shall not own, develop, or manage or operate energy storage facilities. So this is well, it's very important, but DCO should not own it. So, and what is important here is there are specific network codes for energy storage and aggregations are foreseen. So let's go a little bit further. So, and what is the conclusion from the RESOLVE project for the regulation part? There are regulation needs for the low voltage networks, flexibility in distribution networks of the E directive is established that distribution system operators should procure the services from providers which with a transparent, non-discriminatory and market-based procedure. So that means that, well, we have the DSOs, and the DSOs should procure this flexibility they need for their networks with a market-based procedure. That means that, well, we probably don't need have a strict market or local market in place, but we have to have some procurement strategy on a free market. Could be also a bilateral market. So here, the main issues lies how novel assets like storage may participate in such market-based procedures. So this is an open question. Probably in the panel we'll discuss about how this could happen. And one important issue is here that if we are establishing like these market-based procedures to use flexibility in distribution networks, so it is needed to explore new approaches regarding retribution of distribution operators, because we need to take into account the operational expenditure of the grids. So what does this mean? When we were thinking as a possible business model that we have, for example, the case to avoid like congestions, that means to avoid investment in grid assets, which is CapEx. And we replace this through flexibility services. We are talking about OpEx. So that is very important that we are shifting from CapEx to OpEx. And this is very important because we need then to rethink our retribution policy for DCOs in that sense. And this is also that stakeholders has identified. So, well, let's take a close look on the standardization needs for the ICT system. So we identified that the common information model is a crucial model for our system. It is a core standard for the transition to smart grids from the traditional grids. So, and here we were proposing modeling of information based on Resolved of the measurements, the forecasts, grid model, grid status, grid configuration, grid schedule, and faults. So that is all what I wanted to tell you. I wanted to keep it short, as I noticed that I was the last one. So I'm open for any question that you have regarding to this document we made.
Thank you, Andreas. I think you already quite highlighted important aspects of standardizations within the ICT sectors. And I think we're looking a lot into this in all the other projects under Horizon or national projects throughout Europe. But maybe just a quick follow-up question would be then, how does this knowledge of this white paper that you developed could be then used now in the next steps or in the next phase of Horizon, could be Horizon Europe? Could you highlight a bit more on how do you see your contributions there?
Yeah, or probably there are two. The main point here is we have to work both on regulation and both on the technology here. And one of regulations is for sure to develop like this CapEx, OpEx based models in order to enhance the flexibility market. Without the change of regulation, we will not see a very, very a broad flexibility market, because otherwise, the utility will invest in because they get investments refunded, while OpEx will be not refunded. So they will prefer to invest. So we will not really push the market in Europe if we don't change regulation. So research on regulation is very important. On the other hand, the integration of the services, the integration of ICT services with the in the traditional grid, in particular the standard CIM or other standards that enhance integration are also very, very important. We should work on that. And also, probably not mentioned here in this presentation, but also very important, as Heribert told us, it must be also secure. So that, I think, that are the key points of where we should work in future.
Okay, thank you. Thank you, Andreas. Thank you very much for a presentation and then also highlighting this very comment. So we will be hearing from Andreas right after the break with the panel discussion, which is I think very interesting for myself as well. And for now, we are launching a poll because you have heard about all the different innovations developed throughout the years of Resolve project. And you heard about different challenges that each of the technology can solve on its own, but in combination can be very valuable and very fruitful for a distribution system operator or for charge point operators and all the other actors that are now very active in the energy landscape in Europe. So you are now seeing a poll on your screen, and I would really appreciate that you can just quickly answer the poll. You can just insert your answers as you see fit. It's very straightforward, I think, the questions there. So with that, we will be taking a short break now for around 10 minutes. So around my clock, it's 11:26. So we will be back by 11:36. And then we will dive into the panel discussion where we will be talking about how to accommodate all these renewables within our low voltage network. And we will be having a very fantastic panel actually that is being joined from all across different domains, but also actors throughout European energy ecosystem. So we really look forward to having you there, and see you in then 10 minutes. Thank you.
The European project Resolved is showing that with technology we can tackle the challenges of the energy transition in the distribution electricity network. We are now in the network of the electricity network of Estabanell, in particular in the low voltage part. This is the part of the grid that connects directly to our houses, but it's also the part of the network to which we connect more and more self-consumption devices, so for example photovoltaics, or we connect more and more electric vehicles. And the grid is not designed for this, so this represents a technological challenge for the distribution network. Estabanell doesn't want to stop these changes that will make our energy system greener, and so we are finding new innovative solutions to create the smart low voltage grid. And it's a project in collaboration with universities and research centers from 5 different countries.
Resolve project has 2 kinds of battery. We have ion lithium battery systems, and also we have lead battery. The main difference among both battery is the electrical density. Ion lithium has more electrical density than lead battery. All kind of battery, both battery, are managed from a powertrain device to provide the capacity to interact with renewable sources in the electrical grid. The main challenge for the Resolve project is how to move from a traditional electrical grid, a power grid, to a powerful grid in terms of to engage our society and becomes more sustainable. Also, we have low voltage switchgear. That's the way to explain how it's working is like a switch of the real way to move the electricity according to the best needs from the consumers.
Doncs nosaltres el projecte Resolve ens implica un marge de temps molt important, degut a que aquí on s'està efectuant és aquí a l'Esquirol, i és un municipi on el tenim bastant separat del tema de la xarxa. Llavors, qualsevol problema que tenim a la xarxa ens implica un temps de desplaçament, el qual, doncs, gràcies a aquest projecte, podem arribar a temps i els clients no estan afectats, ja que amb les bateries ens podem alimentar, doncs, tots els clients d'aquesta zona.
In a social framework where the fight against climate change has become a priority, the energy transition has become one of the most relevant drivers to achieve the necessary decarbonization of the economy. We are fully committed with this global objective. Stabanay Distribució is contributing locally to extend the network of charging infrastructures for electric vehicles and is promoting the connection of self-consumption installations. In this context, innovation activities becomes more and more relevant for our company, and projects like Result gives Stabanay Distribució an opportunity to understand better two things. First of all, the effects that will arise when massive deployment of electric vehicles, distributed generation, and energy storage is spread over our network. And secondly, the new devices based mainly in power electronic devices that will be generated to control the network and to maintain and even improve the power quality and the continuity of service that we are delivering to our customers.
Hello and welcome back. I hope you had a nice break. We had a little nice music here from our production team, so it was a bit enlightening to start the panel discussion. So without any further ado, I would like to give floor to Andreas. And as I mentioned before the break, that there will be a discussion about how do we accommodate renewables in our low voltage grid. So Professor Andreas, floor is yours. You can start sharing your screen and then moderate the panel discussion as you see fit.
Yeah, thank you very much. So I will try to share now. Okay. So, okay, hope I can see. I will go to presenter mode.
Yes.
So it is working. Okay. Probably you see it. Okay, thank you very much. I think I don't have to present myself because I just have to present myself. So welcome to this panel discussion. So, well, what I wanted to do in this panel discussion is to discuss a little bit about some insights that our experts that we have invited, our panelists, that they can tell us their vision about what should happen in the future. So I are stating here some facts that we know that we have a digital transformation. This is happening. This is a fact. We know about the energy transition. This is also a fact. And we know how important is the empowerment of the consumers. So, well, and these three issues, we want to find answer in, well, within the Resolve projects, but also with all the other initiatives that our panelists have. Who is the stakeholder there, how it should happen, and when, or what is the timeline for that? So for this discussion, I have a really, really good panel. And this is, here I present you very briefly our panelists. Well, I have to please excuse myself that I probably will skip some part of your CVs because you have a very, very, very good CV, so, and very long. So good CV means long CV. So we would be talking about your CV all day. So we have here first Alicia Carrasco. She is Executive Director of Entle Aggregation and Flexibility. So she has co-founded Smart EAN. She has co-founded this Entle Aggregation Flexibility, CEO of Olivo Energy. She's active in energy transition, and so also, but it is with Director of Regulation of Digital Siemens. She has worked for Standards & Poor's, etc. She has a very, very nice curriculum. So Alicia, please say hello to our audience.
So hello, Andreas, and thank you very much for the introduction. So in terms of who I think are going to be the main stakeholders and the new stakeholders, I think at the end this is all landed into the consumers and how they're going to be engaging and connecting their resources to the grid and to the electricity system as a whole. So thank you for your introduction, Andreas.
Thank you. Next, we have Timothenis Ioannidis, who is a senior researcher at ITI. So he has electrical computer PhD, and he is with this research center and has interest in microgrids, smart grids, building automation, decentralized frameworks, blockchain, computer vision, human behavior analysis, and visual analysis. Timothenis, if you can say hello.
Hello, also my colleague from Delta, Apostolos Tsourlakis, will join as he's part of our member. Thanks for the introduction. for some reason, I don't have my camera to be initiated, so I apologize for this.
Yeah, don't worry. It is your opinion is the important one. So yes, here your colleague Apostolos Tsoulakis is also invited here. He is postdoctoral fellow, and he is responsible for project technical management at third ITI. So he is a research associate, and his main interests are microgrids, smart grids, building automation, biotechnology, nanotechnology, and nanoscience. So Apostolos, please, if you're here and can say hello.
Yeah, yes, he is joining. So he is joining because somehow the link did not come to him, but not a problem. He will join shortly. Okay.
Yeah, don't worry. We will say hello later. So next we have Venizelos Eftimiou. Well, he is from the FOSS Research Center for Sustainable Energy in University of Cyprus in Cyprus. So he has an impressive curricular or worked for Electricity Authority of Cyprus. And then he is in the steering committee of ATP-IP, SNAD and PV, set plan, Horizon 2020 program committee. He is also chairman of the FOSS. So thank you, Eftimiou. Please, can you say hello?
Yeah, hello, good afternoon. I'm happy to be here with you to discuss all these very important issues.
Yeah, okay, thank you very much. So, and well, next we have Kari Mäki. He is research professor in smart energy system of VTT Technical Research Center of Finland. So he is with VTT since 2010. He has several worked in several international networks and projects. He is involved in ERA, ISGAN, Mission Innovation, and all these initiatives are focusing on smart grids. He is interested in smart energy systems, smart grid sector integration, digitalization, etc. So, Kari, if you can say hello.
Yeah, hello, and pleasure to be here. And yeah, thank you for very interesting presentations so far, and looking forward for interesting discussions.
Thank you. So we have also with us Hendrik Bindner. He is senior researcher and research group leader of the Energy System Management Group for Center for Electric Power and Energy of DTU. So he has an impressive curricular regarding the research in smart grid. So I will not mention everything. Sorry for that. It would be very long. But he is in the SINA-Lab and Power Lab DK. He has participated in several European research projects and have advised 20 PhDs, different aspects of modeling, control, management of smart grids. Hendrik, please say hello to our audience.
Yes, hello. And as Kai mentioned, it has been very nice presentations, and I'm looking forward to this panel.
Thank you. So, and next we have Ignacio Cuerva. He is CEO of the Grupo Cuerva. He has experience as a member of plenary session and executive committees in several strategic important commissions, and he is head of production of Sakir. And he is a civil engineer, has executive MBA, and he has some executive programs. He has experience in renewable energy in Spain and Latin America, and he is focused on the transformation of the traditional grids into the digital and advanced smart grid. So Ignacio, please, if you can say hello. Let's see. Probably he has some connection problems. So I will go to our last.
Sorry for that, Andreas.
Okay.
Hello, everyone, and thank you for having me here. Congratulations for the program and for the session, because it is being very, very interesting. So thank you very much.
Thank you. So, well, and last but not least, we have here Per Gjerlov, and he is director of R&D of Schneider Electric Norway. He has 10 years experience as vice president of energy in Schneider Norway, 20 years as utility manager, CCO Norgesnet, and he is expert in medium voltage business. So thank you, Per. Can you say hello?
Hello, everyone. I'm Per Gjerlov, and thank you for the introduction, Andreas. I have been working within or with the DSOs for all my life, so probably I can have some experience that will bring in some elements to the discussions later on. Thank you.
So, thank you very much. So now we have talked a lot about ourselves. So now I will raise some questions, and I thought about some facts that we can see in the past, and I stated some questions. So first fact is we see that there we have a volatility of it's rapidly increasing of electricity markets. So that means that prices are going up. If you heard about the Texas issue, their consumers get from the electricity price for 5 days thousands of dollars of bills. So what is happening here? And that is creating an increasing need for flexible response in the system. So with your vision, how can DSO, probably it's not on the distribution operator, but it's all the distribution business, in particular in low voltage, provided this flexibility system. Probably I will throw this question first to Alicia. She is involved in flexibility, in a flexibility organization. Probably she can start with the round of answers for that question.
Well, I think the vision I would like to share is I think the DSOs first, they need to plan how much flexibility they might need in the grid. For that, they have to go through a simulation capacity or a simulation program to understand how much flexibility they will need, and then therefore they will use the flexibility around. So I think they do have a strong role in promoting the rollout of distributed energy resources as a means of solving some congestion, but also as a means for consumers to avoid using electricity when it's more demanding for the system. So I think the signal that the DSO can do after planning and simulating how much flexibility they will need through mapping or through signals of where do they need the flexibility, I think it's going to be very accurate on understanding where to locate this flexibility. So I think they do have a strong voice on the development and the rollout of flexibility in the electricity system. Thank you.
Yeah, very interesting point. What do you think? How can this DSO try to find out how much flexibility they need? Probably they're one who are more in the research of electricity networks. For example, Hendrik, can you tell me what is your viewpoint here?
I think the important thing for the DSOs in terms of flexibility are sort of twofold. One is that they should ensure that flexibility can be transported through their network so that it can be made available at the system level, where the flexibility can also play an important role. And then I think the most important thing in this context here is that flexibility will be integrated as part of the business for operating as the DSOs, and this goes all the way through the chain of different processes that the DSO has, and from what has been a lot of focus here, estimating what is the state of the network, but also how can flexibility be requested in an efficient way, and how can they assess the value of flexibility in relation to other alternatives like grid reinforcements or grid expansion. So it should be integrated as an opportunity on equal terms as all the others, in order to enable aggregators to establish their business around providing the flexibility. I think that's sort of the key thing, as I see here, that could be the role for the DSOs.
Okay, it's interesting. Probably from the DSO point of view, as I don't know if we have like someone here that has more the DSO point of view, not the researcher point of view. What is for you important? I don't know if you have, or if someone has here an opinion.
Yes, if I can take the floor, Venizelos. I was the DSO of Cyprus for a number of years. And so from that angle, I would say that the DSO, I think, is critically important. And I would like to add to what Henrik has already said, that we need additional tools. I mean, simulation models, in order for the DSO to be able to analyze through the analytical tools that he has today that is not complete. They don't have the capabilities of demand response, for example, or smart charging of batteries, for example, or these smart solutions that Resolve has put forward. These require to be modeled correctly, to be analyzed in the 10-year plan of the DSOs, and be in a position to plan the system, taking into consideration how flexibility can be on equal footing, be taken into consideration instead of strengthening just the system or more copper in the ground or whatever. So Henrik has said, yes, it's all the way we need to do that, and flexibility has to take the role that it can play in the day-to-day operation of the system, but we have to be in a position to analyze the system, plan it correctly, and then day ahead to plan the operation of the system the following day based on the forecasting conditions that are already presented today in Resolve project. So I think this is fundamental if we are going to move forward with the DSO really playing the role that is expected to facilitate the way forward and allow flexibility to play a very important active role in how we operate the system.
Okay, so that is very interesting. So if someone wants to add here something.
Yes, as Venizelos and Henrik said, it is one of the main challenges, and if we add to this the future challenge, trying to be or closer to the real time, we can imagine a very very high difficult challenges with regards to the continuous analyzing and grid monitoring and the role of the digital twin and the requirements from the flexibility in each area. So trying to join all these kind of pieces, we are moving to this kind of integrated system, which made the DSO for sure the necessity to be ready for.
Okay, thank you, Ignacio. And now this plays to back the ball to the people in research. So I don't know, Kari, if you have or Demosthenes, if you have a vision about that.
Who can I take the?
Yeah, sure.
Yes. So Demosthenes Ioannidis. Also, a short comment can be made also from my colleague Apostolos to see in particular how we are addressing this need from DSO or aggregators in Delta. What I can say is that the volatility with the distributed renewables is something that affects increasingly the need of new tools, as already been pointed by the other speakers. For us, it's very important to know in very advanced and detailed and robust the flexibility of its LV ecosystem. This means residential buildings, tertiary buildings that reside within the LV system. So whatever we can do in order to relieve DSOs from this demand and with the new tools, for instance, we are putting in Delta fog intelligence, so we can foster with some embedded devices close to the electricity consumption or production to improve, let's say, the flexibility analysis and the service that can be offered to the DSO. I will say only this part because there are also other kind of incentives that can come through, let's say, more proactive, like technologies like the incentivization of the LV consumers or prosumers to participate to flexibility markets. And from this is my point of view, that DSOs needs to be aware of the new tools that are coming from the research community and that are in good TRL and can facilitate their business cases from my side.
Okay, it's very it's true. Let's I'm sorry that I'm not asking everyone. So let's make a transition to this next fact, next question. So, because we're probably, we were talking about like flexibility, and here this leads to the question of value creation. A significant value creation in the smart grid is from the smart grid for all stakeholders. That means that is utility regulators, customers, equipment vendors. We discussed this because we had the vision that we have, for example, prosumers that can offer their flexibility. We have DSOs that can use the flexibility. So what is the value chain that we already talked about is now are not like only focused on the DSL, only in one single narrow sector. It's broader. So and so that is broadening us to or giving us the question to what is your vision about about the different business cases that make happen that such a value chain that we saw that we can use the flexibility in the DSO business can happen. So, and that is very important question. So they say, okay, well, we have like the need of the flexibility. So, but what business models we have to create here? And here, probably I will give the word to Per. Probably to start, because he is in the vendor business, so he is very close to research, but also close to the customers and the stakeholders and moving around. So probably he has some vision about that.
Yes, sure. I see that one of the challenges or hindrances in this is that the DSO need to have incentives for doing this kind of flexibility business, and they also need to be allowed to do it. So here in Norway, we see that the regulator NVE has very strictly rules what the DSO can do and how they can make business on such flexibility. And they cannot, for example, own the battery in the grid. It has to be owned by someone else. So it's very kind of complicated for the DSO to start new businesses, at least here in Norway. And I think the situation is the same all over Europe, that they are regulated very strictly.
Okay, that is true. So, and how is this seen from the point of view of, for example, like the associations that you, for example, Alicia, you know the Spanish case, you are in an association for flexibility. How do you see that for particular the Spanish case?
Yes, for us right now it's quite interesting because we are opening regulations that are about to create a space for aggregation and for flexibility. So that means that different business cases are going to be allowed. So first, in principle, and following what the energy directive tell us, the electricity market directive tell us, storage and charging points are going to be the capacity and the flexibility they can provide, will be managed privately and will be offered to the DSOs and to the system by private by consumers and whoever is between the consumers and the users of the flexibility that they have. So we have retailers offering aggregation to the system operators, shortly to the DSOs. When the markets for DSO are open, yet in Spain we have to implement the Article 32 for the directive that have to prove with that the DSOs, the CMC and the regulator have to say whether the DSOs will buy, is sufficient that DSOs buy flexibility or no. And once they say that, then we will have some boxes for flexibility markets. So with that, we see the independent aggregator providing the value of flexibility to DSOs and the system operators and the market, also retailers offering this service, also communities, local energy communities and renewable energy communities offering this service to the DSO, to the market and to the system operators. And also we will see energy efficiency companies and more, any kind of company offering services to the consumers will have to look at how to manage this flexibility and provide the service and interface with the DSO, interface with the market and interface with the system operators. So with that, in Spain, we are in a very exciting moment because it is true that for a few years, our regulators were not so fast, but today we have the market opening within this year to all the different business opportunities and business models that I have mentioned before. So we are in a very exciting moment right now in Spain.
It seems that is very interesting. So that we have probably different velocities in Europe, probably steered all by the E-directive. So it is moving sometimes more faster, sometimes slower. So I will give the word to Kari. What is your viewpoint here? And you're in the opposite way. There's Norway, Finland is another other side of the continent. How is your feeling about the regulation here, and what what is the value chain here, and for all stakeholders?
Yeah, I mean, regulation, that's very good thing to pick up here. So that has a very strong impact and also very much affects what kind of role the DSO can actually assume in this field. So I guess the Finnish case is very close to the Norwegian case, for instance. So we have some issues with storage ownership and other things, and also for instance flexibility is mostly through really like market energy market mechanisms, and then the distribution network at the moment is seen mostly like an enabler or channel for that. Of course, the discussion and the development is such that also flexibility should be more and more benefiting the distribution network, but we are at the moment a bit lacking that. So, and I think this is very important point at the moment. And maybe to widen up a bit, if we think about the flexibility within the DSOs, so we are going more and more, first of all, across different sectors. So we are integrating buildings, integrating mobility, and so on. At the same time, we are also going into smaller and smaller units in terms of flexibility. So practically smaller volumes we are looking at. But on the same, we also enabled more through some IoT and connectivity solutions, which is a good thing, of course. But this brings us to the situation that we need more and more, like more cost-efficient ways of engaging the flexibility that is very distributed in the system. And at least we have been thinking that we need more like system-to-system interfaces instead of interfacing like individual devices. We need to build like cloud-to-cloud interfaces, which will enable this. And we have been talking about sub-aggregator models where we are building interfaces between different actors. For instance, EV charging operator, for instance, if we can do that through the system interfaces, then that can be much more cost-effective. So that is maybe one example. We have been looking at this sub-aggregator model in quite several fields actually, and that's quite promising. And yeah, one example for new kind of value chain maybe.
Yeah, that's very interesting. And I want also to get the viewpoint probably from the case of Cyprus, because it's an island. So it's probably the flexibility has a much more value there, and probably this could be a good sandbox for new models. What do you think, Venizelos?
Yeah, we said it many times that islands can be the test beds for new technologies and the evolution of technologies. Unfortunately, we are not, we didn't do as much in that direction of being sandboxes of solutions to the rest of Europe up to now, although to be correct, Europe has seen this value. And I think recently, in the recent years, when I say the last couple to 3 years, they have seen that islands are a crucial point in the evolution process. And so I totally agree with you that areas like Cyprus and smaller islands are areas where we can try all these technologies, and we can be a real test bed, because we are talking about comparatively small areas of energy, and we can be real test beds to a lot of these technologies. And in essence, here I think you have taken down that smart grids are creating businesses that we should utilize for the benefit of end users. And for us here in Cyprus, the flexibility is becoming a much more desirable need now, because we are already near maximum penetration of renewables, and we are an isolated system. We heavily depend on solutions that we are discussing today. And so to that effect, is not 2030, so 2035 that we need the smart grid really deployed and operated, and the smartness to be around in order to utilize smart charging, for example, of electric vehicles, or solutions that will give us the benefits of flexibility. We need it much earlier. And I would say much earlier, from year 2025, for example, we need to utilize and exploit the capabilities of storage. Otherwise, we reach the limit of penetration on the network, and this is not a good signal. So from my perspective, I think that the DSOs have a very important role, although they cannot be an active participant in the market. This is the case, but they have a very important role because they can be the very good facilitator of the intelligence of the grid to provide the solutions and and have it available, all that we have discussed today for the project, and a lot more that is coming through research to be really employed and be available for the market to pick up, for aggregators to pick up, for storage owners to utilize, for demand flexibility and demand response capabilities to flourish and be on equal footing with the rest. But I think here we are lacking a lot in regulation and in grid rules. They are far more behind the technology evolution. And here I think is of critical importance that this moves ahead and help countries to develop these solutions forward. And I think Cyprus is facing this problem. We don't have an operating market as yet, and so that's a real handicap.
Okay, it's interesting to see that probably regulation is one important part that is like breaking or hindering too much the technical, the innovative products. May I rush to the next question? And there we are talking about innovative products. And here, innovative products and solutions across the whole value chain, and they have probably a mutual impact on the distribution system. They're popping up, and we have seen this in this project, or also the sister project like Delta or whatever. There are some innovative products, and well, we have seen it in the past. For example, we have with electric vehicle chargers, etc., etc. And well, what is and here probably in order to the utility business is a very, very traditional business here. And here, what is the vision about like new partnership or unorthodox partnerships that for integrating for that integrated solutions that are needed? For example, we talked before about the need of like connecting different services, systems of systems, and connecting that systems. Or for example, another unorthodox player could be Google or Apple in the demand side management business, etc. So how is this impacting this? Probably here I will ask for Ignacio, probably for your viewpoint from the business point of view, because I saw that you had a business point background. What is your viewpoint here?
Yeah, definitely this is one of the biggest questions, I guess, for all the distributors, not only here in Europe, but also in all over the world. What will be the real business with the cable? What will be the real business with the infrastructure? And from that point of view, we think that we are in a similar situation as telcos were many years ago, when the cable was the real business and was under a model of scarcity of infrastructure, where we were the most important people in the past, probably. But we have seen how telcos has struggled with the situation, trying to attract or to grasp the new business that is developing above the infrastructure, where services are the real valuable thing for the customer. And this is the most important challenge from our point of view. How is the customer, if we are trying to become a real customer-centric company, how is the perception of the value from the customer with regards to the electricity? Because probably the electricity in the future will be absolutely transparent and for free. whilst the real business will be in the services we are able or not to provide above the infrastructure. So from that point of view, it is for us, it was our decision to create a totally independent company and project trying to disrupt the business and to disrupt the business models, even fighting with our current business. But it is so difficult to change and to transform the mindset in a such an established sector. That is really a challenge for all of us as distributors and businesses, how to be in this new level, in this new field of the energy sector. So this is our point of view, and we are trying to move forward with this kind of initiatives out of the current business.
Mm-hmm. Okay, that's interesting. So I saw that Alicia had also wanted to.
I guess you were mentioning about new players, and then going after what Ignacio just said, they are doing a Grupo Cuerva. I think there is strong potential for new players, but it's exactly what Ignacio said, is the mindset. So if you have the knowledge about how your lines work, if you know what the energy transition is bringing, the capacity, the innovation, and also the regulations, you have to somehow shake the mindset and propose your own business towards the future. And I think one example, and I wanted to do it before knowing that Ignacio was going to be the person giving the response, is that I think what Grupo Cuerva is doing to take this, to embrace all the challenges and to create business opportunities, to create innovation for the current system and for the future opportunities, I think this is an example to follow, because this is not only for new players. New players are welcome, but also the current players have the opportunity to innovate, and they know the system, they know the sector better than anyone else. So I think this is a very important message. Mindset, we have to change the mindset, and then to welcome new players, but also to support that the current players promote innovation within the companies. So I think this is the main messages I would like to give.
Okay. That's interesting. So, and here, probably I want to ask now, like from the Nordic section, probably Henrik, can you, what is your viewpoint about that? How you feel that in here for you in Denmark are experienced that probably partnerships are shifting and value chain is shifting, so partnerships are shifting, or ICT is pushing into the energy business. How you feel that? What is your viewpoint here?
It is, as you say, also the situation in Denmark that there is this push for increased innovation in the electricity sector, and one way that materializes is that it becomes evident that it is necessary to further separate the operation of the network, so that you have interfaces to the network. Then on top of that you can have these new players come in and provide services to the system via a well-defined interface, so that they have something that they can develop their business towards, you can say in the upstream, and have the freedom, because they're decoupled from the physical system, to develop the business models towards the end customers. So there is a push for this separation of how to provide services to the physical system and how to develop business models towards the customers. So I think that's a very strong push here at the moment, so that you can create a solid foundation for the aggregators, so that they can provide flexibility services, yes, but they can compound it with other types of services for the end customers.
No, that's an interesting point. Yeah, to combine that. So it's to make it compatible the whole system, no, because it's like to have such interfaces to, or like customize the services to the or to the needs of the sector and needs of the customers and etc. So from the ICT point of view, Demosthenes, probably you have something to add how such interfaces or such needs or for these partnerships we have here.
Yes. I will put a small context, and then I think that from what we do in research innovation action like Delta can be pinpointed by Apostolos. What we want to do, it's very important, is that, for instance, to have access to this market also, and to provide services in the end in the distribution grid, also the small producers. So the ones that cannot participate in the relevant markets easily, and they want to have collisions, so collisions and cooperations between them, introducing concepts like the virtual nodes, as we call it. It's part of a virtual power plant concept, where they can aggregate the portfolio that they have, and this integrated asset can be then used by the aggregators that are providing services to DSOs. This is an alternative business cases that we're exploiting for the future of the smart grid. My colleague Apostolos can comment what are the key aspects there and technologies that we can put, and to follow up then the discussion with the other panelists on this.
Hello from my side as well. Apologies for my technical problems. I think that we have to take into consideration also the customer side. As customers become more active and the vision is to participate in the markets directly, it is imperative to discuss partnership with the customers directly, as well as all involved stakeholders in between. And to achieve that, as it has already been mentioned, it is critical to handle interoperability issues. So for all of these partnerships, either we are talking about new products to the distribution grid itself or to the customers, it is imperative to tackle technical issues and technical barriers. So these also introduce new players, because we have new products, we have new services, new functionalities, new systems, and these come along with a lot of business models, a lot of business potential, and that can also alleviate problems and technical constraints from the DSO perspective as well.
Oh, it's interesting. So that leads us probably. I don't control so much the timing, so probably that you will interrupt me when we have finished the time. So, but I want to go to the last question that I want to drop. So, and we were talking about transformation, business models, new value chains. So disruptive technologies are for sure, it's something interesting. We have like that probably there are a lot of technology in development, but here in our project we developed the PED as like a silver bullet or something that will change and transform the market. So and this is attracting capital, talent, attention, etc. So what is your so to having this new disruptive technologies? It's like Tesla in the market, which is basically a tablet with wheels. So and what is your vision about those new players? What is needed for this? And the power market, or what is needed on the power market to create sufficient change in the market? So that we have heard that we need a change of mindset, blah blah blah. But do we need that push or before Tesla was born, everyone talked about electric vehicles, so no one pushed it sufficiently. So probably I will drop the question to on the vendor side. Probably it's fair. Do you want to have like a PD, which is the silver bullet that you can sell in with like where to your clients and change them, make this disruption in the distribution system? How do you see it? Will this happen?
I think it is very important to kind of build everything with open standards, not too much tailor-made. We have seen that in the previous projects that if we do too much tailor-made and have too much instability, no one will participate. They just regret to participate in the kind of the system. So I feel that we need to have solid backbones, easy to hook into, to avoid redesign when we scale it up, and to use existing equipment just kind of completed in a new system, in a new way to set it up. Because when we start to use new players with new tailor-made systems, it starts to be very complicated and very unstable, and we lose the attention from the end user.
So evolution, then revolution, and right, it's a good point. We cannot change all the lines. We are. And that is a very good point. From the others, is there a comment to that, or?
I mean, if I may, somehow I would really focus on the customers in the future, and especially, for instance, different communities that are building on different levels. I think this is very like a interesting area. And they maybe need a bit to be empowered still to get into reality. But for instance, there are like a very good developing concepts for the secondary substation level. What could happen there? And I think an excellent example was already presented today through this project. But really like some kind of community service center brought onto the secondary substation level with everything like EVs and community PVs and everything there, and then also looking at the local flexibility market or local peer-to-peer market within that area. This is one kind of vision that we have been thinking about, and this could be really somehow promising. And also, if we think about a bit more about technologies, there could also be like a DC grid provided for customers who want to have that, and of course hybrid AC and DC provided. And then in case we find like a business model, maybe like a totally new operator for this kind of a community center, this could be maybe a game changer. Okay. At the moment, and then I also think that if there would be such system, then maybe you could start to gather more and more services outside of that, and not only as I said, different kind of peer-to-peer markets, but also of course provision of flexibility towards the upper grid and everything. So that could be a really nice combination of different things. And of course, that's only one example, but not quite concrete.
Yeah, that's very interesting one. So Alicia have some comments.
Yes, I would like to react to what we need to create sufficient change in the market. And I think if we look, for instance, what happened in the UK, in terms of flexibility and local use of flexibility by the DSOs, is very important the fact that they took a commitment on flexibility. So if we manage that the European Union mandate a commitment on flexibility on peak demand, by 5% on 2025 or 10% by 2030, or both, I will say this will be promoting and sending the signals to develop flexibility solutions. And we've seen that this is why the UK is quite developed and advanced on how much and how many different models they are doing today for DSOs to use flexibility. And it's because they have a target, a voluntary target to use flexibility. So if we extend this to the rest of the countries, this will promote and create the sufficient change that we need. I just wanted to say this part. Thank you.
Okay, interesting. Also, an aspect were standards and open standards to interconnect different services. So, what is probably the standardization here is probably important to connect the different services, as we before talked about the systems, the interfaces between different systems, etc. So I would not like to over use my time slot, because it's they say to me that we are probably finishing. So, but I would like to drop the last question. So, how can we improve this standardization effort that we need in future? Because we need to make compatible this different services, the new players, the old equipment, old business models, mix it with the new one. How we can do this, and how can we create this interface? It probably, or everyone can probably say a sentence how it is done, and to finish this round of question.
Well, in my opinion, the fact that the Commission is putting a lot of effort in pushing research and innovation to go in the direction of open standards and interoperability, and giving so much importance to this, and also how this will link the various vectors and not taking only one-dimensional, let's say, electricity vector, but having all vectors within the spectrum of energy to play an equal footing in how they contribute to the energy mix. This, together with the DC that is coming back into our lives, I think is a direction that is going to change a lot in the years to come.
Okay, so probably is there any other opinion to that?
Yeah, I could also come with my take on this. I think it is very important with standards, and one way forward, I think, is that as what is happening at the system level, where they are creating common markets for flexibility. I think it is also important that that the same approach is being taken at the distribution level all over Europe, so that it is possible for aggregators and for equipment suppliers to deliver to these markets, simply because the whole driver in this is that it should be cheap. Basically, smart grids is all about piggybacking on existing resources. So the integration costs and transaction costs should be extremely low, and the only way to achieve that is through standardization. So there should be some kind of standard model for using flexibility at the distribution level. The challenge is that not all distribution networks are created equal, and the business is not organized all in the same way all over Europe. So it is not easy, but I think that is a good driver actually achieving these things.
Okay, thank you. It seems that we are at the end of our my panel. So I just want to tell. I had a comment in the floor. Ramon Gayat from Estomel told us that we have a lot of standards. But we need interoperability. I think that the idea is in this direction. We need interoperability, and I think that the idea is that we need to make the systems work together and creating like somehow a system of systems that is smoothly working together and lowering the cost of smart grid. So thank you very much to our exclusive panel. I think we had a very interesting discussion, a lot of different viewpoints. So I thank also to the organizers that you gave us a little bit some extra time for our discussions.
Yes, no, absolutely. Thank you, Andreas, and thank you, everyone. I think it was very enlightening for myself. So personally, I think a lot of really diverse comments and very interesting discussion there. So thank you so much for taking the time out and giving us these insights. So without any further ado, as we go to the last and final segment of today's event, and as you have now heard about Resolve project, why it was started, the story of all the different innovations that were developed, and why it is important in today's context of accommodating renewable energy. So with the final segment of today's event, we would like to highlight what were the exciting things that already happened during the Resolve time, so that what we aim is to deliver this impact in the sustainable society that we live in and we want to live in the future. So without any further ado, I would like to give floor to my colleagues here at Smart Innovation Norway. Sankit and my other colleague Heidi will tell a bit more about how they have already did some success with the project, and what more you guys listening today can do by joining the next day. So we will unshare our screen, and then maybe Sankit, you can share it from here. Yes, now you can try maybe.
Now I'm sharing my screen. Can you?
Yes, we can see your screen. Can you put it in the presentation mode? Yes, now actually physically the floor is yours.
Thank you very much, Farhan. And just a quick introduction of myself. I'm Sankit, and I'm leading the work package on business models, exploitation, and standardization, where I'm working together with the UPC and UDG on different aspects. The key task leaders in the work package, and also, of course, collaborating with all our partners. We had very interesting presentations before where our technology developers presented doing in the project and what has been the outcomes and results of the piloting, which is very important and interesting. And then the question which brings us here is that what to do from here. And for that reason, we from Smart Innovation Norway have been working closely with all the partners for exploitation of the project outcomes. And there are different things going on during the project lifetime and will be going on after the project as well. So partners have been from their end putting a lot of efforts in creating new projects, exploiting, commercializing the technologies which has been developing. And together with Smart Innovation Norway, we are pushing the boundaries further. And this also sets the tone for the day 2 of the event, which is tomorrow, and which is a close interaction with the interesting or relevant stakeholders who see there is some potential with the technology together with them, and they want to take the technology further, for example, through some exploitation efforts. We will go through the different possibilities which we want to discuss and talk about tomorrow. But before that, we also want to sort of share our exploitation efforts, what we have done, and what are the success stories coming out of Resolve. So in this slide, as you can see, we have initiated a lot of Horizon projects and also follow-up commercial projects with our consortium partners. And we will give a, let's say, a very quick overview of different projects which we have been initiating. So first one, which you can see here, there's no logic of the sequence. We just put the interesting success stories over here. And one of the success story is of Horizon project called ELAND. It's an innovation action, which is led by Smart Innovation Norway. And my colleague Heidi is the scientific coordinator of the project. And I will ask her to just provide some information about the project and how we are taking the work from Resolve forward. Heidi, you.
Thanks, Sanket. From ELAND, basically, it all actually also started from Resolved. So by joining the Resolved consortium, Smart Innovation Norway met the guys from UDG and from ICOM, and we get to know better. And Smart Innovation had an idea for a project where we would like to focus on the local energy systems. We would like to focus on the sector coupling, and we already had some initiatives towards India. So these were the topics we were sort of interested in, and we saw that by combining forces with ICOM and UDG as the core partners, and then inviting a bunch of other partners, we could maybe create an interesting project proposal, and we ended up succeeding. So ELAND project is actually one of the exploitation outcomes from Resolved, and it's a project focusing on creating a toolbox which has tools focusing on community building, focusing on business, and focusing on technology. I think it's very fruitful to join these projects with different TRLs, because then we can bring the solutions into next level with new collaborations and new projects. Thank you.
Thank you, Heidi. And I think this also brings an important point which was raised by our panelist Efthymiou from Cyprus, that we should not just look into the integration part, but only the electricity domain, but also other vectors. And this is what we are also focusing in ELAND, is not just the electricity part of the energy, but connecting different vectors together in order to integrate more renewable energy. So it is good to know that our panelists also share our view, which we are now going forward in ELAND. And then similar to ELAND, there is another Horizon 2020 project, which is Fever, which is led by our partner, that is Intracom Telecom, and Ilias, who is here, is the project coordinator, and I would ask him to talk about the project a bit and provide an overview of it.
Thank you, Sanket. Good afternoon. So I think as the presentations today were evolving, we realized that focused on key enabling technologies for the DSOs, either storage-based or ICT-based tools for better observability and controllability. On the other hand, we thought that we should broaden a bit the scope and consider the whole ecosystem and take into account also the other stakeholders that can contribute in a better distribution grid, stable, more efficient. And we all heard just in the session before this final presentation, the key dimension to consider. Therefore, in Fever, we consider the part of flexibility, not only from the viewpoint of those who need flexibility like the DSOs, but also from the viewpoint of those who can and can provide this flexibility. And therefore, Fever was a natural evolution of prototyped in stakeholders in light of
Elias, can you hear me? Elias, there is some issue with your microphone because your voice was breaking. Elias, can you hear us? I think there's some issue with this audio. Elias, you there? Can you hear us? No, unfortunately, your voice is not coming through and your voice was breaking. So I will just move to the next speaker and we can come back to you when your audio is fixed. Yeah, as highlighted by Elias previously as well, I mean, Resolved is technically a low TRL project, and then moving forward, as we also got insights from panelists that we should more focus on the business part and going towards the services direction, which also brings the technology towards more maturity. And with that in mind, we have interesting follow-up pilots, which is done by our Slovenian partner, which is Comsensus, and they have two pilots. One is in Slovenia and another with the Italian DSO. Now, I would like to ask Miha to just briefly talk about it.
Yeah, sure. Hi. Thank you, Sanket. As I have mentioned during my presentation before, presenting the results of the Resolved that we are now exploiting. So we have two pilots. So the first one is about the tighter collaboration between TSO and DSO in terms of assets controlling from the operations center. So the situation is that there is in the capital of Slovenia, Ljubljana, there is a small area, commercial and industry, which is a closed industrial site and commercial. It's a closed energy system as well that is powered by the DSO, I think via 3 substations. And within this area, there has been a large battery installed as a part of one demo project that they are running. And it is actually for the purposes of ancillary services for the TSO. So the real-time monitoring and control solution that is based on our devices will now actually be used to test the controlled islanding and then the reconnection of the site back to the main grid. So the infrastructure is now installed, and towards the spring there will be the tests performed. And the second one is actually the replication with the Italian DSO. Actually, this is also part of now already 2 Horizon 2020 projects where we are taking the results from the Resolved, so the instruments, and we have deployed them at the Italian DSO site, and there we are actually also looking at so the events detection and then mitigation in accordance with the distributed energy resources that are installed there. So this is actually taking us further from the results focused in Resolved on the kind of the intersection between medium and low voltage, more to the medium voltage and the control domain, not only the observability. This is it in brief.
Providing this overview, and let me be very quick because we are running out of time. So these were the different projects which we have been initiated by our consortium. And there, we have also received additional funding from Research Council of Norway to exploit the outcomes further with Norwegian DSOs. So we will soon start with this project as well, where we target to have activities with almost all the DSOs in Norway and see how we can actually implement the pilots or the technologies in the Norwegian context. And finally, I would like to introduce Energy in the Cloud, which is a spin-off from our partner company, that is Astabanel, which plans to take a lot of ideas, inspiration, and also the technology from Resolved into their new business. And for that, I will ask Ramon to share his experience with the Energy in the Cloud and what he thinks the company would be doing going forward. And Ramon, since we are running time, I would ask you to be very concise. So let's say 5 to 6 minutes. And I have your slides with me, so I can go through the slides as you ask me. Otherwise, feel free to share as well. But I would recommend that I do it from here so that we are fast.
Okay.
Yes, Ramon.
Yes, okay. Can you hear me?
Perfectly well.
Okay, so thank you, Sanket, and thanks at all the audience to attend the Resolve Final event day. Okay, let me explain about Energy in the Cloud. Legally born last July and functionally has started this January. As a result of invest a lot of efforts coming from European Union calls, fund from Astabanel company and myself. All together, fostering to move the vertical way to manage as a traditional DSO toward horizontal way based on agile methods that DSO have to integrate in their part of the network to provide all kind of solution that they know that respect. This is important because always DSOs or the electrical sector are providing a lot of solution from the end users, but it's not usually listen the user what expect. This is the starting point and the knowledge achieved from several partners involved in European consortium projects like Resolve. Astabanel understood Energy in the Cloud like a challenging base to provide solution at this sector. That certainly it's changing quickly, facing the energy transition going towards a more and more electric world. Energy in the Cloud becomes an innovative, adaptable and disruptive startup in the world of medium and low power management by transforming current distribution networks into dynamic networks with a distributed assets based on cutting-edge power electronics technology, taking advantage of software with distributed intelligence and data, and giving us the ability participation at all actors in the energy sector, from the first electron, that means from the first electron generated to the end user that is consumed. So Energy in the Cloud is revolutioning the next generation of the proximity energy management by inventing an innovative, highly flexible market solutions based on the exploitation and real-time information that optimize resources, promote distributed assets at its respective with the environment. Let me say also that from Resolve, Energy in the Cloud perspective aims to make most of the DSO assets and network get closer to all users of the distribution network, because the last mile of the electrical network actually is the region that they have to interact. Taking from bottom-up side, we want to bring more visibility and smart controllability at the last mile network to maximize the distributed energy resources integration. Well, Energy in the Cloud foresee to bring concept quasi-grid, meaning quasi is almost understood as a whole solution to be respectful in the areas in terms of avoid to build new traditional electrical infrastructure to match the benefits of the grids in a network, thus avoiding inequality in the quality of supply in the infrastructure that have a lot of DSO in the whole Europe. Another key is foster the whole concept of a dynamic grid, providing at all DSOs the capability to manage certain region of its network as several coupled grids. Both concepts could be offered to any Europe DSOs. Also as a service like ICOM platform or requirements like PED, consensus PMO, UDG forecasting tools, and so on. And this is the Energy in the Cloud solutions. Just to finalize, to conclude, from Estabanell exploitation, we considering our long years working in this kind of met and research, decide to create Energy in the Cloud as a startup. The business model is focused to aims to make most of the DSO assets and network, because Energy in the Cloud is able to solve the challenge of the electrical network and overcome the investment obstacles based on software as a service. To conclude, let me say that Energy in the Cloud is as a nexus to improve relationship among DSOs, aggregators, and balance responsible parties, highlighting the DSO infrastructure without loss of the comfort and capabilities from active users under the renewables electrical work closer and closer to the end users. Thank you, Sanket.
Thank you, Ramon. And sorry that we had limited time for your presentation, but this is one of the most exciting outcomes which we have from results. So definitely we would like to market or talk more about it, but we have less time today, but we will definitely find more time in coming day to discuss about these ideas and see how we together with the participants create more such cases. So now, Heidi, the floor is yours and to wrap up the session.
Thank you. Thank you, Sanket. Just quickly before I will have the final words, but to wrap up our joint session here, you saw some good examples of exploitation opportunities that we have already grasped. And as I mentioned in the morning when I started the session, we are here to achieve more of these. So definitely we look for more projects where we can improve the TRL of the solutions. We look for commercial piloting of the innovations, business-to-business collaborations, academic collaborations, technology transfer. So there's a lot of opportunities from Resolved, and we are very proud of what we've already achieved, and we are eager to achieve more.
Thank you, Heidi. I think it has been a very interactive and very action-packed day today. So it was a lot of presentations compact in one little, I would say, half a day. But we really appreciate that you came today. From myself, I really had a really exciting and interesting day following all these interesting presentations. But finally, if we could conclude today about what goes forward for the next day, Heidi, last words from your side before we end the day.
Absolutely. First of all, I want to start by thanking everyone for staying with us. We are already in the end, but please keep with us maybe 1 minute more so you will hear what I have to say. Thanks for all the speakers today, all the panelists. It was amazing that you had you donated your time and your expertise for us and discussed with us the important issues. And I hope today gave you some insight of what we've done with Resolved almost 3.5 years now. We have still 1 month to go, and we are not stopping now. We are actually speeding up the work. So, so definitely, if you got interested, please join tomorrow for the day 2, where we will work in smaller groups to actually create some concrete outcomes of this session. Some new collaborations, new partnerships could be formed. I don't promise to create new companies tomorrow, but definitely we might do that in the future. Who knows? So please join us. There is still some room for tomorrow, and we have an exciting half a day ahead on tomorrow.
Thank you, Heidi, and thank you very much, everyone, to join today. Follow the discussions. Please, as you can scan this QR code, or my colleagues have put the link in the chat below. So once again, thank you from our side, and we will love to see you in the next day tomorrow. And after that, if you ever want to reach out, please contact us from smartinnovationnorways.com website or through our personal social media channels. We look forward to meeting you in person when the pandemic is over, hopefully soon. Till then, goodbye and have a good day.
Thank you. Bye.
Thank you. Bye-bye.
Bye.